Hello and welcome to the first video of our C# 12 course. I'm excited to introduce to you this powerful and versatile programming language, which is C#, and to show you how it can help you create amazing things. Okay, the goal of this course will be to master the new features of the C# programming language latest update, which is the C# 12 version. So, you may ask, who is this course made for? This course is ideal for beginner programmers with no prior coding experience in any programming language at all. It will also be useful to programmers transitioning from other programming languages, such as Python or perhaps Java. In addition, web developers, game developers, as well as software developers aiming to upgrade their C# skills can take this course as well. Some of the benefits on taking this course includes the fact that you will master the C# 12 key features. You'll build a strong foundation on core concepts and best practices, ensuring you a solid C# development skills. You'll also prepare for real-world applications of C# through integrated projects throughout the course. And finally, you'll gain a competitive edge that is turned out in the job market by mastering this sort of programming language, which is C#. With no further waste of time, let's dive into the video, which is Overview of C#. In this video, we'll go over the following topics to give you a solid foundation on C#, which are what is C#, we'll define it, and give a history of the programming language. Next, we'll explain the key features of C#. That's why you should learn C# with a number of supporting reasons. And finally, we'll list some applications built with C#, some very known and common ones. Let's get into it. Okay, imagine a versatile artist's toolbox packed with brushes, paints, and chisels. C# is your equivalent of a coding toolbox, allowing you to paint vibrant web applications, sculpt robust desktop software, and even craft captivating games. C# is a general-purpose, object-oriented programming language developed by Microsoft, and this language is renowned for the following reasons. First off, we have its readability. The C# syntax resembles natural language, making it easier to understand and an easy-to-write language compared to other more cryptic programming languages. So you can think of it as writing instructions to your computer in English, with a sprinkle of technical magic into it. Next, we have its productivity. The C# language boasts of features like automatic memory management and powerful libraries, saving you time and effort compared to manually handling every technical detail, hence permitting you to focus on crafting your masterpiece, not getting bogged down into the nitty-gritty. And finally, we have the community. The C# programming language has a thriving and supportive community of developers ready to answer your questions, share resources, and help you overcome coding challenges. So, no need to go into it alone in this creative endeavor. So that was for an overview on the C# language. Now, let's get into the key features that make C# 12 stand out. The first feature we'll talk about is the primary constructors. Classes and structs can automatically initialize properties, streamlining object creation and making your code a lot more concise. Next, we'll go on the collection expressions. That's to say, building collections like arrays and lists become a lot more concise. The syntax is a lot more concise, hence reducing unnecessary lines of code and enhancing readability. Optional parameters in lambda expressions, adding flexibility to your lambda by. Specifying optional parameters make your code more adaptable and efficient. Next, we have the ref read-only parameters. We can modify function parameters within the function without affecting the original variable, leading to safer and more predictable code. And then finally, we have performance enhancements. The C#12 optimizes common operations like method calls and property access, making your code run faster and smoother. Apart from the above listed features, there are a lot more. We can say the 5 we have talked about are the major. So next, we'll answer the question why you should learn C#. There are a lot of reasons as to why you as a programmer or beginner or intermediate should learn C#. And the first is that C# sees adversities, that is C# isn't limited to one domain, as it helps you build web applications, mobile apps, games, desktop software, and the like. The possibilities are simply endless with C#. Next, we'll say C# is a future-proof software or a future-proof programming language. As the C# programming language constantly evolves, bringing with it evolution, new features and updates, ensuring your skills remain relevant and valuable in the ever-changing technological landscape. Finally, C# is a highly demanded skill. That's the C# skills are highly sought after in the job market, which simply means learning C# opens your doors to exciting opportunities in various industries. From web development to game design, mastering C# equips you for diverse career paths. Okay, I hope you've been convinced to learn C# so far. But if not, we can list on some applications built with C#. The C#, as you have said earlier, can help build web applications. So the first we'll be talking about websites and web applications. From the e-commerce giants like eBay to social media platforms like LinkedIn, C# powers a back-end logic of countless websites and web applications. But these are just the most renowned. Next, we have desktop softwares like GIMP to productivity apps like Evernote. C# brings desktop software to life and offer a range of functionalities and user experiences. Okay, next let's move on to games. This part we won't say much. We'll simply talk about Unity, which is a popular game engine, and this popular game engine, which is Unity, will leverage C# for developing everything from mobile puzzle games to cheap console titles. We can also talk about enterprise application, as a lot of businesses rely on C# to build robust and scalable enterprise applications, which have handled everything from internal data management to customer relationship systems. Okay, this is just a glimpse into the vast world of C#. By learning C#, you gain the power to create, innovate, and shape the future of technology. Let's continue with this exciting journey in the upcoming videos, where we delve deeper into specific features and build real-world projects. That was it for the overview of C#. Thanks for watching. Hi there C# enthusiasts, and welcome to this video. This video is entitled Evolution of C#, and once more we'll be diving into the exciting world of C#12. The C#12 programming language model has come a long way since its original inception, constantly evolving to meet the demands of modern development. C#12 being the latest chapter on this journey, throughout this video we are going to trace C#'s evolution to appreciate how it shapes to this programming language, of course. And then we'll zoom in on the game-changing features on C#. Okay, let's get started. Our journey begins in the early 2000s with C# 1.0, fresh-faced and full of potential. It brought object-oriented programming to the .NET framework, laying the foundation for what we know today of the language. Also, delegates, events, and properties were added, which are like building blocks of the coding revolution we experienced during that period. Over here, we have a sample code snippet demonstrating how delegates were using C# 1.0. Without wasting any more time, we're going to move on to the next key upgrade of our language, which was C# 2.0, which brought about generics. Upon this upgrade, suddenly reusable code with type safety became a reality, and a boilerplate code became a thing of the past. Iterators and notable types joined the party, making C# even more expressive and powerful. Next one, we had another C# version, which was about a very interesting characteristic, which was a C# 3.0, bringing about a language integrated query, or simply called LINQ. This property simplified data manipulation in C# language, letting us query collections with concise and readable syntax. Also, lambda expressions added an array of elegance, making the C#. Let's talk about C# 5.0, as this was one of the biggest game changers in the C# language, bringing about the asynchronous programming. The async and await keywords became our new best friends, making asynchronous operations smooth and predictable. These features made C# the true good choice for building responsive web pages and applications, for example. And finally, in our list of game-changing upgrades brought about to C# language model in the past is the C# version 7.0. This version brought about pattern matching, which provided a powerful tool for dissecting data structures with ease. Switch expressions and property patterns made code clearer and a lot more expressive. While our wait in catch or finally blocks added a touch of safety and grace to error handling in our language. So we're going through all the game-changing upgrades that came out of the C# language model in the past. Each version of C# brought something special to the table, shaping the language we know today and love, of course. We didn't mention all the versions, just the ones with the most game-changing properties added to them. But with all that said, the C# version 12 takes things to a whole new level, as we are going to see. This language version is packed with features that will make your coding experience smoother, faster, and a lot more enjoyable. With the announced exciting properties and features of this upgrade, such as the primary constructors, collection expressions, optional parameters, and number expressions that we have talked about in the previous video, and that we will still mention in here, the C# 12 update is definitely a game changer in the programming world. In the next videos, we will explore these exciting features in more depth. I hope you enjoyed this journey through the history of C# with all the game-changing evolutions that came about in the past and present. That was it for evolution of the C# language. Thanks for watching. Hello everyone. In this lecture, we are going to set up our development environment so that we can proceed to write our first lines of code using C#. First, we will need to set up the .NET SDK. What is the .NET SDK? The .NET Software Development Kit is an essential toolkit for developers working with the .NET platform. It supports the creation of applications across multiple platforms, like Windows, macOS, and Linux. It is very helpful, allowing you to create various applications that run on multiple platforms. This is the toolkit we will use to help write our C# code. You need this to be able to run C# code on your machine. What are the uses and benefits of the SDK? They are various and multiple. I'm going to focus on the most essential. With the .NET SDK, developers can build many types of applications, including web applications using ASP.NET Core. We will develop a web application later in this course. For desktop applications for Windows, you can use WPF, Windows Forms, to create applications easily. The SDK also supports cross-platform GUI applications using .NET Maui, or Avalonia. It's useful in creating console applications for various utilities, mobile applications, cloud applications with optimized performance and scalability, and even games using frameworks like Unity. The .NET SDK is cross-platform compatible, which means you can develop on and run your applications on Windows, Linux, and macOS, enhancing the flexibility and reach of your applications. Additionally, it has a comprehensive and large extension of libraries and APIs, which provide access to a vast collection of libraries and APIs that can be used to implement functionalities, ranging from file input-output to networking and data access. This is where we are going to end. You now have a brief overview of what .NET is. Let's proceed by installing it. To install the SDK, go to .net.microsoft.com. And when you arrive, you can directly download the latest version. The website will detect the system and operating system you are using and will offer a compatible version. By clicking here, you will download the latest version. As of now, the latest version is 8.0.6. You can see it here. By clicking here, you can proceed by downloading and then install and follow the instructions, which are very simple and straightforward. After we have installed .NET on our machine, we can write C# code through the command line interface. However, we need an IDE for easier and more appropriate code development. We are going to use Visual Studio in this case. If you prefer, you can also use Visual Studio Code. They have almost the same functionalities and are very similar. It's not going to cause any issue. I'm going to start with Visual Studio, and later in the course we might also use Visual Studio Code to develop some applications. On Windows, you can click on Download Visual Studio. Alright, the download is going to start here, but since I already have installed it on my machine, I think I'll just cancel the download. Once the download is complete, you can proceed with the installation process. Here you have all the list of tools and functionalities offered by Visual Studio. For the installation, you might need assistance. When installing, you will follow the steps outlined. You will make sure your system is ready for Visual Studio by checking the system requirements to see if it can run on your machine, though it runs on a lot of systems with no issues. You initiate the installation after the download has been completed. From your download folder in the file manager of your machine, you can double-click on the Visual Studio Setup.exe to start the installation. If you receive the User Account Control dialog, it asks you to acknowledge the Microsoft license terms and Microsoft privacy statement. Choose Continue to proceed with the installation. Also, you need to choose workloads, which is very important as we are going to use them later. You can choose basic workloads such as ASP.NET and web development to develop ASP.NET web pages and enable live preview. To build responsive apps with Blazor, you might also need to choose desktop and mobile workloads for cross-platform development. That's okay. If you have those workloads, you can install others later, but it's appropriate to install them now. After you have done that, you can simply click on Install. You can also install some individual components, but as a beginner, you don't need them. You might also have to choose the install language package, but it usually defaults to the system language. If your machine is using English, you can proceed with that. After the installation is complete, you are ready to write your first line of code. And we are going to see that in the next lecture. So, that is it for setting up the development environment. In the next lecture, we will write our first lines of code. Hi, and welcome back C# Explorers. In this video, as the title indicates, we will be opening the doors to the heart of C# programming with variables and data types. Get ready to master the art of storing and organizing your data like a C# programmer, because these concepts are the cornerstone of building any meaningful application. Let's get started. We'll begin straight on with variables. So, variables in C#, like in many other programming languages, are named containers that hold values in your code. That is like little memory spaces where you can store data, be it a text, an integer, or observing a Boolean value. So in C#, this is how variables are being created and assigned in the programming language. So here we're going to teach you how to create the variable in C#. First one, you see the int here, is the data type. That's in C#, you name the data type before naming the variable itself. The next one we have my age as the variable name. It may be age here, or my age, or any other variable name you choose. But the trick in naming variables in C# is that it's always preferable to start with a small letter. The name variables with a capital letter starting. It's just for best practices. There's no written documentation for that. And next, we have the assignment operator, which is the equal to sign, as you can see here. And it's used to store the value 25 in this case. With that said, let's go on to the practical way of creating and using variables in C#. For that, we're going to open our Visual Studio 2022 IDE. We'll create a new project. The project we're going to create, the console app, in this case. And give it next. Let's name it My First App. Okay, we're going to leave it. We are going to use the .NET 8.0 because it has a long-term support. But feel free to use the .NET 7.0. We are going to use top-level statements as it permits us to write code without including them into a class. And then we create our project, our console app in this case. First, we are going to be declaring and initializing variables, and then we are going to be printing out the variables we declared and initialized. Let's move to the declaration part. As in the PowerPoint we saw earlier, we are going to try to initialize. We are going to try to declare a variable named myAge. So, the variable is an integer type. Give it a space, then we name it myAge equals to, and let's say equals to 21. Now we finish the statement with a semicolon. This squiggly line, you can see here, indicates the variable has been assigned but never has been used. So here you can simply say print myAge. And if you run this, we should get this console printing out 21 here, and that's all. Okay, click any button to get rid of the window. There are many different ways of declaring and initializing a variable. In this case, we declared and initialized a variable in a single line. But we may as well declare the variable on this line. Then we come on a separate line and we initialize our variable. And if we want this, we should get the same thing. You see, we still have the same result. Our console appears on screen with the 21 printed and asking us to exit. So that was it for declaring, initializing, and printing out the variables in C#. Next, we're moving on to data types. So, what are data types in C#? Basically, data types are like blueprints that define what kind of data a variable can hold, as we saw in the previous example. They ensure everything is organized and compatible in your code. Just like using the right boxes for your belongings while traveling, for example. So here are some of the most common data types in C# programming. The first one is the one we saw earlier, which is the int or integer. They are used for integers that has whole numbers like 40 to -50 or even 0. Next, we have the double. They are used for floating point numbers. That is decimal numbers or numbers with a decimal point. Like this, you have here 3.14, which is the value for pi, or 1.5 exponential 2. Then we have strings. Strings are used for text values like hello world, print code that comes by default when creating the console app. Then we have the bool for Boolean values. Basically, they print out true or false, that is, used to make decisions. And finally, one of the most used data types is char for characters. That's simply used to express single characters like A or C, or perhaps a hashtag. You could use them to grade some products or anything using a single character. So let's move into the practical part of data types, so we get to know how they're being used better. So let's get back to our code editor and try creating a few other variables, particularly when initializing a few other variables with different data types. And this one is a name, so use a string. You see we have the red squiggly lines, which are to tell us we are out of context simply because the string that they type have to be in inverted commas, as you can see, else it won't be recognized as a string. Then let's say he's 5'11", using the decimal instead. Then finally, using the bool to know if perhaps John Smith is married. Probably a difficult question to answer, but let's assume a man of age 21 is probably not married, hence false. You see on the Visual Studio IDE, you can sometimes get your lines finished for you just by hitting Tab key. That is it for variables that we have been declared. Next, let's try printing each of these variables. Okay, now we saw a simple print in the variables we created. We are going to try use string concatenation, so we can add a string, then add the variable value. Let me get to each other here. Let's say include a string. Also, full name column with a space. Then add a plus sign here. I will put name. We will try printing it. We should have full name colon. Then we have John Smith exactly there. It's just one way in which you can do that. The way in which you can do that is without the plus. So instead, just want with adding curly braces, and you first have a variable name there. But if you just leave it at this imprint, you have full name, colon, open braces, name, colon, close. So we have to format this string by adding a $sign in front. So the compiler knows this isn't just a string, but it's actually our variable up here. And you see, once we run this, we should have the same result as previously. So that is it. Full name, colon, John Smith. One thing you notice is that if you have an error, like a serious error, like here for example, this variable doesn't exist. If you try running, it will tell you the real error. Basically, the IDE will inform you you have errors in your code and it just can't compile it. So you should try to check it out. At this point, you see it even gives you tips to correct the error. Like if the GE doesn't exist in our current context, that's basically all. So we are going to try to add all these variables we created, and we need to add them on separate lines, just like this. Now we have all the information provided here: full name, age, height, and model test. So far, we have learned how to declare variables and initialize them, as well as print out the variables using string concatenation and formatting of strings. Also, we have learned the most basic data types used in C# programming. With your knowledge of string concatenation and string formatting, you can gain in this lesson. I would like you to try printing out this line over here using the variables and data types we just created earlier. In the next video, we will dive deeper into operators, those handy tools that let humans build data and create cool expressions that were variables and data types. Thanks for watching. Hi, and welcome back to our C# 12 fundamentals journey. Today we embark on a vital mission, which is laying the foundation for program execution through essential operations. Consider this video as your bootcamp to wielding the fundamental tools of data manipulation and decision-making in C# programming. Okay, before we get into basic operation, let's talk about the previous lecture where I gave a little assignment concerning printing out variables using string concatenation or perhaps even string formatting. So, if you write out something like this, you should get the results we have. That's the expected result. So yes, we have the same statement, exactly how it was in the previous one. So naturally, there may be many other ways of printing this out, or even giving out the same information. Not always in this same sentence format. Okay, let's move into basic operations. So basically, in the core of any program lies the symphony of operations. I tried the addition, operation, subtraction, comparison, and ultimately, all of these operations orchestrate data to fulfill our programming goals. In C#, two of these operations become our trusted instruments, allowing us to craft efficient and precise solutions. So let's familiarize ourselves with these invaluable tools. So first off, we are going to start with arithmetic operations. So basically, arithmetic operators are simply addition, subtraction, multiplication, division, and modular arithmetic. So let's declare a few integers here. So integer, say integer a, assign our a to 1. We could simply declare a second integer on a second number. We can actually add a comma at this level, and we add a second integer. As you can see, the IDE proposes other solutions. So this one, we're going to add a b. I will assign b to 20. Let's assign a to, say, 12. Then we end this with a semicolon. The first operation we are going to need is the sum equation, that is to add the two of them. So the degree of value for sum is called sum. We assign sum to a plus b. Then, if we try printing out this, we see a sum of a and b equals sum. Once we run this, we see our sum of a and b is exactly 32. Then we get to difference here, degree of value for difference. And difference will simply be a minus b, a different integer, and here we are going to declare the product, and we'll use a by b, as it then you have the quotient a. Then you give it a backslash, and with a semicolon, and then in the end, you give the last one a remainder. You give it a third type. Okay, so try this by printing each of them. For this point, let's try something. Let's instead make this 20, and let's have this to be 10 instead. Once we run the program, we see we have sum of a and b. 30 different times, the product of the 100. The quotient is 20, and the remainder of a divided by b is 0, respectively. So you see these basic arithmetical operations actually work perfectly when correctly written in C#. Okay, that's our arithmetical operations. Let's move on to our next operation type, which are logical operations. Logical operators basically work with Boolean expressions to give out true or false statement. The three basic logical operators known are and, or, and not. Though we have the not, and not, or. We are once more going to declare a few variables. Let's give the variable x as an x to true. Then we have the variable y as an x to false. Next time, let's try to find the result of these Boolean expressions x and y under each of the logical operators which exist. So I declare the variable for the and expression. Let's name it and return. What's more of a return than result? And return. Return to x, and this is how to represent an operator without using and symbol twice. So X and Y, and return and return. And if we run our console application, we shall have it here at the bottom and returns false exactly. So let's try to separate this a little bit. Let's make sure we have good separation between both of them by printing an empty string at the end of our aromatics operators. So you see here, it's better. There is a separation between both of them. That's simply because we printed an empty string back there. To represent O, simply give it X, and for O, we have this straight line twice, and then give Y, and this. Make all an idea. And finally for not, with a bool of not return, let's say not X here. And we simply represent the not S by putting an exclamation mark followed by the integer we are changing it to not. So the AND simply multiplies both of the Boolean expressions as true and false, or 1 and 0, and the 1 and 0 gives 0. So it will give a false. The OR simply is the addition of Boolean operators. So that will be 1 plus 0, and that will give a 1, which will be a true. And finally, the not gives the opposite of the operator. So if in the case here X is true, so it will give not true, which will be false. The CFR expected results, which are false, true, and false. So that for the logical operators in C#. We hope you notice the symbols which are used to represent each logical operator in C#. Okay, so far we have seen all the arithmetic operators as well as the logical operators. The last basic operator we are going to be going through is the OR, because many of them are the comparison operators. You may have noticed that each time I put a double slash before writing a line of code, it just doesn't appear in the console application. Points I click on the run, that's simply because there's double 4 slashes. As you see them right here, are the characters required to declare comments in your code. So be sure to use them. That's it. Let's move to the configuration of Windows, which I think it's greater than, less than, and ultimately equals to. So we have the greater than or equal to, as well as less than or equals to. So let's get through it. First, I'm going to declare 2 other integers here. For you to note that the comparison operator most often works with integers, because you just can compare strings or characters. So I declare 2 other variables, since comparisons are supposed to give out answers like true or false. I need to know if a comparison is wrong or right. The result of such operations are always brilliant. So let's try that. Equal. Let's declare variable is equal. So let's assign the variable is equal to C, equal. So to know if a variable, to determine if a variable is equal to another, we use the equal to sign twice. Don't confuse with the assignment operator, which is simply using the equal to sign once. This is a common feature in most programming languages, like Python, for example. So you earn your language, a semicolon, and that's good. And this normally will return us a false value. So let's just comment it here, false. Then let's move to our console and try printing it out. You see is equal to half a false there. We can further modify our console printing by adding, you have the C and D, they're simply like this, and here you can see we have 3 is equal to 5. It gives us a false. Though it would have been better with a no Y answer, of course, but that's the language. So let's go to the next comparison. If we go to CPB, it's not equal. Here we have the C not equal to D, and logically, that should give us a true as result. The next equation we'll be moving is C is greater, and here we should have a C greater than D that should give us a false answer, because C is definitely less than D. Here, C is less than G, that should give us a true. Then let's implement it by adding greater than or equals to and less than or equals to. So I went to add the consoles. Okay, so at this point we have written our code for Pantana. Each of these results modify the strings to be accompanied to the result as well. So we run our console, and yes, you have it. Each of the results according to PC. Is 3 equal to 5 false? Is 3 not equal to 5 false? So these are the mistakes you shouldn't commit. Always convert the variable as well. So we notice our code didn't give us any error, of course. Basically, the code is correct, but it doesn't execute what we want it to do. Okay, let's do this. Once more, hold on. Our program, you see, we have it is 3 equal to 5 false. Is 3 not equal to 5 true? Is 3 greater than 5 false? Is 3 less than 5 true? Is 3 greater than or equal to 5 false? Is 3 greater than or equal to 5 true? Basically, if you change any of the integers we have over here, you should have without which match. Let's see if we have a 5 here instead of us, make them to be the same. You have the same thing, 5 equals to 5, not equal to 2, greater than no. It's not less than, it's greater than or equal to true, is less than or equal to true as well. So that is that for comparison operators in C#. So next time, I would like to try combining each of these operators we have seen in this video. Combine operators. Okay, so using the integers we have initialized above, I'm going to try this. So let's call it bool result. Let's call it the result, just like this. And in that, in this case, we're going to use the B, C, and D. Let's convert the C to 3. This should give us something like D plus C. D plus C is 8. A2 definitely be less than 10 over here. So this should give us something like a false. False. And this I should be true. Because of the 5 minus 3, which will be 2 and 2, is less than 10. That should be something like a force. Because an n of force and 2 is force. So that is it. You have a result which is false, as expected. Okay, that is that for our operators in C#. Nationalities tools require dedication and especially practice. So I advise you to experiment and explore, as well as embrace the joy of discovering while working with these physical creators using the C# programming language. And remember, mistakes are just stepping stones. You should just embrace them as opportunities to refine your programming techniques on this C# foundation. Okay, next we'll conquer the realm of conditional statements in our C# course, which are the if statements. Else if and else as well as looks. So that was basic operations in the C# 12 course. Thanks for watching. Hi, and welcome esteemed C# enthusiasts. As we embark into the voyage straight to the heart of C# 12, which is with the if statements, prepare to dissect this fundamental tool not as a mere branching mechanism, but as a cornerstone of architectural brilliance. Okay, let's get started. Before we get into the topic of our video, which is if statements, let's first talk about all these lines of code that you see on the screen here. So here you see we have a using system with a semicolon in the end. Then we have class program with open and closed braces. Down here then, inside the class program, we have the static void main. Basically, you have just a name function with open, braces, and close. Carry braces as well. So let's start with the using statement. This line over here simply makes us know that we are using the system module or the program. For example, in normal cases, we want to print our console application. It takes some words, something like console.writeLine. Then we include a text. Okay, like in this case. It's simply possible because we are using this other system. So the printing of this line and using the console up here just after the printing is possible with the help of system. And that's it. Without this being written here, we will need to include a system, perhaps like this. But ultimately, there is even more important, especially for printing, because as we know, C#12 supports top-level statements. Next, we have this class program. In C#, a class is a fundamental building block of object-oriented programming. That is a blueprint or attempt to redefine the structure or behavior of objects in your program. So the MTQL basis. But yeah, there is something in it. But the care of basis indicate the body of the class. And inside your class, you can define data members like constants and fields, as well as function members. Also, the program class precisely, because here we are not defining any class. We are defining the program class precisely. It's often used as an entry point for C# programs, and it typically contains the main method, which I'm going to get in, which I'm going to describe in a few moments. Next, we have the main method, which is being described in the program class. And first, let's talk about the static. The static keywords indicate the main method that can be called without creating an instance of the class. That is, it belongs to the class itself rather than an instance of the class. Next one, we have the void keyword, which specifies that the main method does not return a value. That's very important. And finally, we have the main method itself, which is the main being the name of the method is a default name for entry point in C# program. That simply means that most programs start being executed from the main method declaration, as you see right here. We didn't use all of these like introductory syntax in our programs because C#12, as we said earlier, support top-level statements. The top-level statements are valid for just a few operations, like very common variable declaration and very common operations like printing or writing lines in the console. But with what we are supposed to do today, we are using conditionals unique. All of these right here. So let's get into it. Okay. The if statement offers us a binary choice that makes it easy to read. If this or this, its basic form in C# tools, as it transforms itself into a versatile tool, empowering you to scale programs with flow, precision of a master build. Can't think of it as a meticulously crafted gate evaluating expressions to determine the program's flow. So this is how an if did when is written in C#. First type in if, then open the bracket where you have to put the conditional. Then you open and close the query braces where you put what happens in case the conditions is respected, which is specified in the carry basis. Naturally, you have a semicircle. So let's take, for example, variable here, an integer. So variable named age and assigning the value of 19. So let's say if age greater than 18, let's give it greater than or equal to 18. Let's consider perhaps you want to sign up for a credit card or something that requires you to be an adult. So let's say if age greater than or equal to 18, then we have our console printing. Let's say you print out, you are an adult. And then if you run or call, let's say you are reprinting, you are an adult. The process will change this to, let's say, 40. It just doesn't print anything because we have created an instance for if the condition is different from this. Okay, that was it for the instruments. Next, we're going to move to the way to better accommodate our code, which would be by using the else statement. So here we have if age is greater than 18, the console puts out, you are an adult. What if you are younger than 18, like in our case here? We give it an else. Here we have some errors that I think today. Oh, I forgot our SIM card here. Voila. It gave us a, sorry, you are too young instead of a blank shape. So apart from if and else, you still have another very important conditional statement, which is the else if conditional statement. So if and else are good if you have just one choice or the other, but in case you have 3 or more choices, the else if can be a real game changer. So once you give the else if a secret half, you can sign in once you're 18 and above. You need to be less than 60 years old in order to do it. And we'll say age less than 16. Here we see, sorry, you are too old to sign in. So now let's test if our code works as we expect. Here, enter 65 years. It gives you an adult. So this is one of the interesting things about programming. Here, this is simply because you could once use the integer, then it goes if age greater than or equals to 18. You want to add up. Once this condition is met, the code simply stops there. It doesn't move further. That's simply because the compiler interface the code line by line. In order to mitigate this, what we could do is I could add this here instead. And this should make our group work as expected. Be a mistake somewhere. Okay, you're supposed to be a great data age greater than 60. You're too old to sign up. Sorry, you're too old to sign. Exactly what you wanted to test out. So those were the if-else, if and else statements, the conditional statements we have in C#. So the C# tool will erase the if statement further by allowing you to control nested conditional frameworks. So a nested if statement or nested if statements with the else and else if possible are simply if statements within if statements. So let's get to that. So in this case, instead of putting in the age with the last system, we can simply nest the age limit within the within one if statement using the nested if. So at this point, we get rid of our else block. They will move into our if statement. So this is how to do the nested if. Within the if, with the indentation, we add if. In this case, let's say if the age greater than 60, we'll give it nested less than 60. So the console says, from that, you're an adult. You can sign up. They will move to the else within our if statement. So the else will simply be age being greater than 60, like the case of the age at 65 we saw earlier. So we have to take note of the indentation. This here is very important. Indentation is exactly 4 spaces to the left, but that shouldn't be a problem if you're using the Visual Studio. The little version especially has indentation. It's great automatically once you hit the enter key on your keyboard under the E statement, or else even the LCF else. So now let's run our program once more. So without changing anything, we are sure we haven't messed up everything. Okay, so we are through here, and I'll give it a 19, which is between the age gap. If you want to add a conglomerate, you can sign up. Fine. And I'll give it I'll say 69 this time. It says you are too old to sign up, exactly as we expected. So it says this time we didn't have to go to the hardware store, looking up on which code should go up or which code should go down, while using the if as the compiler interprets the code line by line. If we simply nest the if statement within one if statement, we can go through multiple conditions within a single conditional statement. So, recall in our last video, we talked about basic operators, particularly the logic operators. You can actually use logic operators here to examine 2 conditions at once. So in this case here, let's say if age is greater than 18, then we'll use an operator at age. Then we'll enclose all of these into bases, running this code with a prescribed age gap of 18 and 16. Let's give it a 21 this time. You see it says you are another Conga chicken signer. So you see with this instance as well, you can usually add your L6 tickling. As you can see, we still have evaluated a code that executes what we want to the perfection. Exactly 61. Return 60. You are to auto sign up. So we have to go through a few ways of writing this. Same code. You can still change it in a certain number of ways. That is to say how versatile the if, else if, and else statements, as well as the operators you can use alongside them. And the nested if statements can make coding easier in C#. So matching the if in its advanced form requires dedication and exploration, which I invite you to do. With diverse branching structures, as we have done throughout this video, and discover the true architectural potential of this versatile tool. Remember the limitation of the A state, mean, is not in there. It does not lie in the A state mean itself, but simply in your imagination and ingenuity. We will be getting to the end of this video. Next, we shall ascend to the lofting heights of loops, and we will examine switch statements as well. So prepare yourself to shape your C# landscape with a mixture of conditional flow. So that was if statements. Thanks for watching. Hi, and welcome esteemed C# architects. We are simply today to embark upon a journey into the heart of algorithmic control rules, or in other words, loops. The loop is a fundamental construct which helps evaluate our programs from mere sequences to symphonies of efficient execution. Loops are conceived as simple becoming loops of repetition. There are three main loops which exist in C#, which are the for loop, the while loop, and the do-while loop, which we are going to be talking about throughout this video. In addition to that, we are going to learn how to do nested loops. Let's get started. Let's begin with a for loop. So a for loop in C# is a control flow statement that allows you to execute a block of code repeatedly for a specific number of times. It's often used when the number of iterations is known in advance. So this is the syntax, the basic syntax of a for loop. Here it is. So you have for loop. First you declare the for operator, then into the bracket here, the initialization. That is, you've initialized a variable which you'll be iterating on. You have the condition for iteration. And then finally, you have the iteration you showed of the incrementation. Then you open your query basis and you have the block of code to be executed in there. Let's try give you a simple example to demonstrate the for loop working mechanism. So for the initialization at this point, you're supposed to declare a variable or assign it. So what's interesting is that you can declare a variable directly inside of the for loop. You can also do it out of the for loop as well, but always still be the same thing. Next, we have the condition. Let's give you the condition. Let's say I should be less than. Then the iteration simply will increment our for loop as I++. So this means the I will be incremented by +1 after each loop. Here, the initialization is at 0, but we could do it at 1 or any other number so far as it's less than the condition, or else the loop just won't run at all. Next, we have our block of code to be executed. It rings out I, for example. Then we run. That's only because the first time the loop runs, the I is at 0. So, I is at 0. It prints out I, which is 0. Then we increment it by 1. It prints out 1, 2, then 3, and 4. Then, once we increment for the last time at I, which will be 5, since I is less than, since I is greater than 5 at this level, the loop breaks and we end up with the result here, despite numbers being printed from 0 to 4. So at this level, if we change this, I'll put a 2 here, for example, we realize the loop actually begins at 2. So that was for loop. The next loop type we're going to be talking about over is the while loop. So a while loop in C# is a control flow statement that allows you to execute a block of code repeatedly based on a specific condition. Unlike us, in the for loop, where the code is being executed a specified number of times, which is being specified in the condition, here the loop continues to execute the block of code as long as the given condition remains true. So here we have the while loop syntax. First up, we have the while keyword, which marks the beginning of the loop and is followed by a set of parentheses, as you can see here, where we include the condition into. Next, the condition itself, which is the part of the code which is evaluated before each iteration of the loop. If the condition is true, the block of code inside the loop will be executed, or else it won't, and the loop will be terminated. In the case where the condition is true, the loop will be iterated and goes back to the condition is found false. And finally, we have these curable writes here, where the block of code to be executed is being placed. Okay, so here, let's try getting practical by creating a real instance where we can use our while loop. First, we initialize the variable, let's say an integer, and let's assign it to 1. Then we place our condition in here. Let's say our condition is j being less than. Then you have a cool. So we just code each time our loop is being run. Like at this point, the first is 1. What that means is the integer is being initialized to 1, and the condition is so far as the j integer is less than 5. And if that is true, the while loop runs with j. We're getting out while loop j. And here we're missing something, which is the implementation. Let's give it a j++. Okay, so now our loop is good. And this result should simply count the number of times the loop goes on to 4. And here you see we have it while loop 1, while loop 2, while loop 3, while loop 4, exactly as expected. So as usual, changing the initialization will simply change the manner with the code. As you can see here we have it pointing 5 times from 0 to up to 4. Let me put it at, let's say, numbers greater than the condition. Let's say 7. The condition will simply never be met, and so the loop will never run. Okay, that was a while loop. That's a good way to make a loop never appear in your program. Simply placing an initial value which doesn't make the condition to be met even a single time. You can do that here as well, and you can see our program doesn't do anything, whereas it runs in the background because the condition in the loop are just never met. In case you want to comment on all this, you just simply have to make this to be a backslash, then a star, and then you have a star and another backslash. This simply makes comments on multiple lines. Once you add this to your code, the backslash and the star, it makes all the lines coming after it to be comments. And to stop, you simply add a star and a backslash, as you see right here. So now let's move on to the do-while loop. Okay, the do-while loop in C# is a type of loop that executes a block of code repeatedly based on a specific condition, just as the while loop. But the key difference in the do-while loop from the while loop is that while the do-while loop will always execute its block of code at least once, even if the condition is false. You'll understand that in a bit. So let's give it a space here, and then we have the do-while loop syntax, which is as follows. So first, we have do, the do keyword, which marks the beginning of the loop. So the block of code following this keyword will be executed at least once, regardless of the condition being met or not. This is because the condition comes after the block of code to be executed. So next time we have a block of code which is supposed to be executed repeatedly, depending on the condition. And finally, we have the while keyword, followed by the condition, which is to govern the execution of a block of code specified right here. Okay, let's try during a real instance for this do-while loop. Just like in a while loop here, our do-while loop requires us to initialize our initial value out of the conditional. So we initialize k equals to 1 in this case. So at this point, we could simply format our string here and add our constants. Value that is k, which will be 1, 2, 3, and so on. Or we can concatenate k, but we could also do something else. We could add an index, a 0 index right here. Then at the end of our clean console, we get a k. This should do exactly the same thing as this, our string concatenation. And that will give us what we wanted, exactly what would have happened in case we concatenated the string or any other thing. So this is just a fancy function, you see. But if you are more comfortable with string concatenation or string formatting, feel free. It's just to be used as a plus. Okay, so far we have gone through the basic ins and outs of the for loops, while loops, as well as the do-while loops in C#. Next, let's move on to the nested loops and see how they change programming with comment all of this. Okay, then we drop this down. That's fine. So a nested loop, just like in the nested if statement, is simply a loop within a loop. So I want to get into the details of all this and see how this functionality in the C# programming language helps us do very interesting things. So to get acquainted with this functionality, what we'll do is we'll create a simple square. We'll print out a square using a loop. The square made out of asterisks, to be precise. This square I'm going to print out the square of 5 asterisks by 5 asterisks. So let's start with the form. So this loop right here simply assigns our integer to 0, and the condition is so far as our integer 1 is less than 5. Now within this, we have a second for loop and a second pair of collaborations, now given the condition there. It should be our console write line that are half and asterisks at the same time. This is called missing correct, but there is actually a problem here, because if we run this, we simply have an I being printed about 2 and 5 times on a separate line each, just like this, as you can see. To solve this problem, instead of using the write line here, we will introduce write. So when you print an I once, it doesn't move to the next line. It does it on the same line. But you see, we still haven't solved the problem, because after the fit one, it doesn't move to the next one to begin the next loop. So we need to add in a way in which once a loop is terminated, it moves to the next line. And to do that, all we need to do is to add in our console write line right here, as the code suggests. And with this, let us add spaces here. Let's see those spaces here, so the code will be not two joint, and it will look a lot more like a square and a triangle. Voila. Square made of asterisks. So as you can see, the use of loops permits us to have a controlled repetition of tasks, as well as algorithmic efficiency. Loops empower us to convert redundancy by encapsulating repetitive tasks within defined boundaries. And finally, loops help the modernization of our code. That is, facilitates code-level abstraction, allow us to encapsulate repetitive functionalities within reusable models. So I hope you found this video interesting. Next one, we'll move into switch statement. Well, that was loops in the C#12 course. Thanks for watching. Hi, and welcome C# architects. Today we'll explore switch statements, which is a powerful tool for crafting efficient multi-way branching logic in your program. So let's prepare to ditch away clunky nested if statements and embrace the elegance and precision of controlled conditional jumps. Okay, let's get started. The switch statement is a control flow statement that allows a variable or expression to be tested for equality against a list of values. It provides an alternative way to write complex if-else statements when there are multiple conditions to be checked in. Okay, so now I'll present to you the basic syntax of a switch statement. This is how a basic switch statement should look like, and I'm going to list some of the key components. First, we have the switch operator, right? Or the switch expression. Then close to the switch expression, we have this open and close brackets here. In these brackets, you are supposed to put in an expression, and this expression is simply the variable which is to be evaluated. Then we have curly braces, which are open and closed. And within these curly braces, we have all the cases to be evaluated. For the first case, you put the expression, which this case is supposed to match. You put in the statements to be executed. Then you break out. Then finally, we have the default, which is simply referring to it. What happens if none of the above mentioned cases are being matched by the expressions? And it prints out a default statement in that case. What you notice is that after each of the cases, the line breaks, which means if one case is met, there's no need of going through all the other cases. It will just stop there and print out the result. With this, you notice that switch statements are particularly useful when you have a single variable or expression to compare against multiple possible values. They can make the code more readable and maintainable than a series of ifs. Receive statements, especially when dealing with a large number of conditions. So, in this video, we are going to try to create a program which tells you if your input is consonant or not. So, try the program. We are going to try each case. Which case is going to respond to any continent, and in case it's not the continent, you have a default statement saying that value is not a continent. So let's try. Okay, so next, we need a way for our user to input value and not just output. So I want to give him the console. This is simply going to prompt an input from the user. Let's place this out. Okay, so let's create a variable and assign that variable to the input from the user. So let's create a variable, string variable. Next, we will move to our switch. I will simply add our variable as the expression to be evaluated. Okay, let's move to our first case. Let's say using the first case to be SA Antarctica. Okay, we have our first case value, which ends with a colon, if you notice well. Next, move our print statement. Let's say we want to print out. Okay, I'll put our console writing yes. In this case, Antarctica is a continent. Then you're going to break out. Okay, and then finally we have our default. Here I think I'm going to all the continents: Antarctica, Europe, Africa, North America, South America, Asia. Okay, let's add in a setter for here. That's how our default segment is going to be. It says simply continent is not a continent. Okay, at the end of this case, we need to add our semicolon. And voila, this code should run just right. See here, we are getting some error. It's talking about the main method, not a suitable entry point. Now we simply remove all this data type and the argument from the bracket after our main method declaration and run it once more. Okay, continent name. Let's go with America. Yes, America is a continent. That's fine. Let's try another name. Let's see Asia. Okay, yes, Asia is a continent. So we can see our code is working. Let's try on our default here. Let's try giving another name. We can even add in a country with a continental size, like Russia. But since it isn't with us in our cases, Russia is not a continent. So this simply prints out our default statement right here. That is, no, not a continent. So that's it. So with this, we can confidently say our code concerning switch cases works just perfectly. Okay, so far we have seen the key properties of switch cases, which are less over the efficient branching, as we avoid if, else, if statements, as well as the nested if statements. Hence, we improve the code's clarity and performance. Good performance simply because we break after each case. We are not forced to go down whole loops to find something. So next, we have multiple conditions which can be handled at once, and also we have explicit fallbacks. That is, since we define a default in case not the condition is met. So a key reminder on the switch statements is simply that the Excel won't denote a finite set of known conditions. So some of the key new parameters added into the C# language with the C# 12 are allowing for even more flexibility and concise comparisons. We have cascading cases, helping you group similar conditions into single cases for improved readability and efficiency. And finally, the early exits. As you can see, we put after each case, in case we made the condition. In case the expression is met on the first second of the case, we need to go right down to the second case. But next, what we are going to talk about, we are going to demonstrate the use of lambda expressions with switch cases. Like this, like switch, continent, go inside, have, wait, display it like this. That will be the continent, switch. Okay, next one in the cases, we actually have the cases too. We won't need to use the case expression here. So we will just type in the case, then we'll assign it to the result with lambda expression. And then we'll just simply an equal to, then a greater than sign. And that is it. Then we'll remove all of these, including the break statement. And I didn't see any colon at here. I meant a comma instead. So we simply repeat this with each of our cases here. So far, we have assigned each of the cases. each of our switch cases to the conditional statements. But now we are left with a default. Since the default will take into any case, that is actually a symbol used to denote default cases when we use lambda expressions in switch. And that is simply the underscore. So we are given underscore because we are greater than, and we assign all the rest exactly as they are. You'll notice here at the end of the default line, we will need to add in a comma, or we need to just leave it blank, and the code understands that's the last line on our switch case statement. But we have an error here, and this is simply because we require a semicolon at the end. Once we've placed in the semicolon, you will notice we have all of these lines, basically makes all of our switch cases incorrect. That's simply because there are only a few types of exceptions, like assignments, and calls can be used as a statement, unlike this case. So we simply convert this into a return statement, which will solve the problem. We can return a statement while in a void main method, because void simply means the code doesn't return anything. So to solve this problem, we simply create a new method which will contain our switch statement. So we right click, click action, and reflect on it. Now extract a method. Let's call it map switch. Fine. I created a new private static method for the map. So our method won't be a void method. Instead, it's going to be a string just like this, so we can return. Okay, naturally, if we want this, it should work as we have our new method with our selected many names, and it's under the main. But that won't happen. You see, the console is generated but just doesn't print anything. That's simply because our method is never called. So to change that, we simply call our method in the main method by assigning the variable to it. So we assign the variable of data type variable, name, our variable output method here, and then at the end of the code, we should be able to print out our method exactly like this. So this might be a bit confusing. So we are done with the code. Now let's try running. And if she worked this time, and you see we have our code prompting us to enter again continent name. So let's try Asia once more. You see it says, yes, Asia is a continent. It shows the input and it shows the default statement right here. So with our default, we should have something like, no, our input is not a continent. Okay, Asia and Russia. No, Russia is not a continent. So that's fine. So you see the code works exactly as previously. But if you don't mind, all this metal creation and assigning right up here. The code is a lot smaller and a lot more readable. So this use of lambda equations simply shortens our code and makes it a lot more readable and exempts us from using eternal and eternal keywords and expressions. So with this, you notice that measuring the switch requires deliberate practice. So I invite you to experiment with diverse conditions, explore pattern matching, and discover the true potential of this elegant branching tool. So in this video, we talked about methods creation, though we didn't go into it a lot. In the next video, we will talk about methods and functions. Well, that was switch statements in the C# library. Of course, thanks for watching. Hello and welcome to our C# programming course. In this video, we'll explore the fundamental concepts of functions and modules in C#12. We will learn how to define, call, and utilize functions and methods to make our code more organized, reusable, and efficient. But before that, let's start by understanding the concept of functions and methods in C#12. Let's get started. So in C#, functions and methods are essential building blocks of code that allow us to encapsulate a set of instructions into a reusable unit. Functions are used in procedural programming, while methods, on the other hand, are also shaped with object-oriented programming instead. Next time, we are going to explore the characteristics of functions and methods. The first and most pressing characteristic of functions and methods is the name. So both methods and functions have a name that uniquely identifies them within the scope of our program. Next, we have parameters. Methods and functions can accept input parameters which are usually located in the braces which follow the function's name. And these parameters are simply variables that are used to pass the value to the method or function for processing. Next, we have the return type. As the name and parameters, both of them have a return type which specifies the type of value that the method or function will return after its execution. If the method or function does not return any value, the return type is specified as void. Then you have the body, which contains the set of instructions or code that defines the function or method's behavior and is simply enclosed in the curly braces preceding a declaration. Next, we have static or non-static. Basically, methods can be static or non-static, whereas static method belongs to the type itself and can be called directly using the type name, while the non-static methods are associated with instances of the type and are called using an instance of the type. Then we have method overloading, which as well as static or non-static concerns all the methods here, and methods can be overloaded, which simply means that multiple methods within the same class can have the same name for different parameters. This allows for feasibility in calling methods with different sets of parameters. And then finally, let's take the return statement to return a value of the specified return type back into the calling code, which is mostly situated in the main method. Okay, these components are essential for defining, using, understanding the behavior of methods and functions in C#. So next, let's move to Visual Studio and try defining a few functions so we'll better understand a lot of these characteristics. Okay, so now we're in our Visual Studio. We'll try defining a simple function and then we'll learn how to call the function we define. In this case, we're going to try defining a function that does modular arithmetic, taking two integers. So simply, we take two integers and find the remainder if one is the first is divided by the second. First, we divide the function, which will be an integer. Okay, we have defined our function in the name mode, which is an integer which takes as parameters x and y. You see here, we directly put the integers x and y, which are the parameters, straight into the function, but we could print it from our user. Then let's go to the body of the function, which will be simply what the function does. Then we'll save the function. Okay, so our function will provide the remainder, which equal x module y. Then we have to return. Okay, so far we have to define our function. We will not use squiggly lines, right? That's simply because our function has been defined, but never has been called. So we are going to get right away into it and call our function right in the heart of our main method, but out of the function's definition right here. Okay, so the point at which we could call our function, we could either create a new variable here, like give it an int. Let's say, remember, they would find the answer using an account. And this is right. It's just fine. And if we want our console using this, we should have something like true divided by 2, which will give you 1. We'll give you another 2. So it should give us something like result equals 1, exactly as expected. We could shorten our code further by simply removing this. This excess variables we created here, and then we could put in the next session, just like this. Now you'll notice we haven't really changed anything. We simply assign our operations directly to the keyboard without using any variables between, and it should give us the same result. Okay, as I suspected, you can choose either way, the one which works best for you, but I will show you the two ways anyway. So what you'll notice is that the functions run within the main method and are simply being printed, or the simple one, the number of times they're called in the name. So if we copy this line of code right here, just like this, and we run it, we should get our result twice. So this is simply it. We avoided writing this simple function many times and just defining it a single time and calling it as many times as we want. You could use different variables, of course. Perhaps you could put a 5. Okay, exactly what we wanted. That was fine. So that was it for functions defining and calling using C#. Next, we are going to see methods. In a sense, methods are very similar to functions. The main difference in the definition is that they are defined within secret classes. In this instance, we are going to create a new class. Let's call it class remember. Okay, just like this. Adding the curly braces. Once we have our class, we are going to add our method. This time, and the method, we are to simply be the function we created earlier. And you see, once we move our function from here out to the main method, we have all these function calling being seen as errors. So now instead, we have a method of data type integer and name mode. It takes in 2 parameters. And this is the function's body, simply finding the modules of x and y. So if we want to successfully call our method within the main method, what we'll do is we'll have to call it the correct way. Since it is within a separate class, we'll have to include the class name close to the method's name. So in this case, we'll add in the name there. But you notice what's being seen as an error. That the remainder, once you read the documentation, says remainder mode is inaccessible due to its protection level. That's mainly due to 2 reasons. The first is because the main method is static, whereas our mode method isn't static. So let's try to correct this. But you see, it hasn't completely solved all our problems. They're still the same at all. That's simply because we haven't decided if our method is a public method or a private method, or perhaps even a protected method. So basically, a public method is accessible to all other methods through our code, whereas a private is accessible only within the class it is specified into. So we'll set this as public. And you see, it was disappeared. So now I'll go through and successfully, exactly 1, 2, and 4, exactly as previously. So you could say we have successfully created a function, defined a function, then called the function, and converted our function to a method within a new class. So similarly, if you recall from the previous switch statements with lambda, expression, example we had earlier in the course, we had something like this where we created a method. We simply evaluated our switch cases and gave out the output in the main method right over here. So in this case, just for better understanding, we could have simply placed this directly in the console write line. What you understand here is that we simply created a method within the same class and called it in the main method. You see here we named it private, and it's still run because we are within the class. But in this case here, we are to name it public because it's out of the class program and within another class. And similarly, we have to specify the class while calling it within the main method. Whereas here, we don't still need to do that at all. Okay, and basically the changes we've made here. I did not consider to remove these arguments here, these parameters, and exactly as we had before. Let's give Asia and see it says exactly as last time. Yes, Asia is a continent. So that basically is to say the method can be created in the same program or out of the same program. Just have to take care of how you define the method. Okay, that was it for define and calling functions and methods in C#. So far, you may have noticed there are some very few differences between functions and methods. But with this PowerPoint, we are going to go through the key differences between these 2 instances. First, we'll go through the differentiating characteristics of functions. Then we'll go through those of methods. First, we have the standalone property. That is, functions are standalone blocks of code that can be defined outside of class, and they are not associated with any specific object or instance, unlike methods. Next one, we have the modularity. That is, the functions promote modularity and code visibility, as they can be called from different parts of the code without the need of object instantiation, as we saw with the methods. Then the categorization, simply saying that in languages like C# or C, they are used to categorize and encapsulate a set of related actions or calculations. And finally, we have the global or local. So those were the key instances, differentiating functions from methods. Now let's move to those differentiating methods from functions. First of all, the fact that methods are associated with classes, simply meaning that they represent the behavior of the class or object and can be called on. Instances of the class. Next, object-oriented, meaning that they are used to manipulate the data and the state of an object within the program. Next, we have the access to the object state, simply saying that methods have access to the data or attribute within the class they are defined and can modify the state of that object in particular. Finally, we have visibility. Just like a public and private resource area, methods have visibility modifiers, which control the accessibility from other parts of the program. In conclusion, assigning functions and methods are crucial for writing modular and maintainable code in C#. I will encourage you to practice writing and using functions and methods in your own programs to gain a deeper understanding of their significance. So that was functions and methods for the C# 12 course. Hi, and welcome esteemed C# architects to this project into our C# 12 course. So this project will be all about creating a console-based task manager using the C# programming language. And with this project, we're going to tackle some of the very interesting C# properties that we have gone through so far. So let's get into creating our project. First, we move over here to the Create New Project. Then, since we're creating a console app, we click on Console App, then Next. I will name it My Task Manager. Okay, this is our project here. Then we're going to add all the headings useful for us to code, since we won't be coding using top-level statements. Okay, at this point, it's okay. Our task manager is going to be managing tasks, of course. And each of these tasks which we create will have properties such as their description, their due dates, if they are completed or not, and their start dates, for example, as well as their task identity, or their identification numbers. So for us to have each of these properties, we need to create a separate class named task where we'll declare each of those. Let's make it public. Then I'll also declare each of the class property variables. First, we'll have an integer for the task ID, then the task description. Next, we'll have the due date, which will be the data type date time. And finally, we'll have its complete root of the Boolean. Next, we're going to add a constructor to simplify the task creation. So our constructor will be named class. We'll be closer to a list in this. And this list is simply going to the initials of the variables we declared up here. And finally, it's completed with 32 true, 32 false. So this is simply because by default, the tasks aren't supposed to be completed yet. Oh, my bad. It was a task, not class. Just like this. Now it all makes sense. Okay. Now we have our class task with each of the properties of each task, like the task ID, description, due date, and its status, whether it's completed or not. And by default, the status is not completed for each of the tasks. So back to our main method, we convert our constructor we declared in the task class, convert it to a list, just like this. So we'll say list task equals to new list task. It's just exactly like this. Okay, with our list created, let's try to initialize an initial sample task here. So we'll say task list due to the bucket one more at the IG. I do the one come, yes. I did the description. Let's call it C# to a project. Then we set the due date to, let's give it datetime.now. Now it's like a method within the datetime class, and we'll use the function at this. If you just hear, we're adding this form this day today at this tree, just like this. Instead of using test list here, we use test list because it's just easier than reading tasks. Okay, so far we have added like a background logic behind the creation of our task for the task manager. And we have an initial sample task here, but we can't print any of it or do anything because we don't have an interface for it. An interface with the supporting printout, the test ID, description, as well as data and time completion stages. And for that, we will have to create a display menu. So at this point, we will create a separate method, and the method will be named display menu. All this sympagness is like a display menu for Task Manager. So first, of course, it's going to display Task Manager, the title of the console application. Okay, but our console application is also going to have menus, like for example, adding tasks, reading tasks, and setting tasks as completed, for example. So I have to add these menus for those. That's the way. So at this point, the first menu here will be the menu 1, which is say, add task. The second menu will simply say, read task, which will be a minute, with task. The third menu will simply say you should mark the task as completed. In case the task is completed before the due date, you simply mark it as completed. Then the fourth menu in this case will be exit. Okay, so you can add as many menus as you want, but you have to add in functions to support the menus. So at this point, we can call our display menu in the main method, like this right here. Okay, so now with our display menu created, let's try running it and see how it is displayed on the console. Okay, fine. Add task, retask, mark task as completed, and then exit. Now we have to find a way to make our task manager a bit more interactive, because at this point it simply displays the display menu, but nothing more. It doesn't ask for the user to create a task, nor does it propose the user to read any of the tasks in it. Okay, so this point will make our code a bit more interactive by adding a point where the console application prompts the user for an input. So using the while loop, here we say while true, the console prompts the user for an input. That simply makes the console constantly prompt the user for an input. So as the console writes, the user will be able to enter the choice. Then we are going to assign the choice, enter all that input to a string. The string value named choice, which will be the user's choice. Okay, just like this. So let's want to code this in the difference. Okay, it says enter our choice. Let's say 1 to add a task. Redux doesn't do anything for 6. Even in routine 4, we see which is to exit. If it doesn't exit, we can continue like this for as long as we have the time to access a while loop, which says true, which basically means the loop is infinite. So we will change that using our cases or switch statements, as I saw earlier in our course. So 3 statements will simply permit us to carry on different operations depending on the value of the choice. So the first case will be case 1. So on the case 1, we have a function which says add task as the first choice represents the add task. But then we have it break out of the switch statement. It will break out of the switch statement, but not out of the while loop. So next one, we'll have a second case, which will be case 2. And case 2 will be another function, which will be read task, then break, and so on and so forth. Depending on the number of choices you have to add in different methods or different functions. And don't forget to include the methods implementations out of the main method as you're calling them into the main. Then case 4. Case 4 says exit, so we will simply print out exiting. So after exiting, we'll have it returned very soon. So at this point here, we are really breaking out of the while loop. And then we'll have our default case, which is in case the choice is neither of the 4 listed above. And you'll have the console printing invalid choice, then break. So let's move to our various functions implementation first. We'll start with the add task. Okay, so to add any task, we need to add that. We need to have a new task ID, description, and a due date as well. So at this point, for the task ID, we will need to, like from the user for a task ID, here we're going to create a simple task ID which increments itself automatically. You have to know. The links are in the description. Next time, I hope you do that. The next try will be nice to the user by criticizing the formats just like this. The problem here is that although the user is going to add the geodate in this format, even if he actually does so, the console read line always reads strings because the console always writes strings and only takes in strings from the user. So even if you put in numbers, it will still be read as strings. So for us to convert the string data type to the data type, we have to pass it into this format. So here, let's have it. You have the same thing to ask in our description. Okay, let's be nice and let's add a final line to tell the user his task has been added. Now let's add the read task function. Okay, since we are at this point, we are opening a different menu. We should have the console having a different title here. Okay, then we have like a table or a grid, which will simply have the task ID, description, geodate, and completed. Instead of completed here, let's add export stages instead. Then we have like this, underline box, and this. Here we are just trying to mimic a user interface. Since we do all this, it will be predicted on the console application. Next time we are going to add a 4-hour loop, which will simply have an iterate through each of the tasks. So we'll say for H for each task that's in task list as it says there. Then know how this conditional. First, I like to convert the stitches because here we simply can't print out true or false. They are booleans. They are like 1 on 0 and all this stuff. So instead, what we have to print here is an instance of the true or false. So we create a separate variable here. Let's name the variable stitches. Then we assign the variable to assign it to whether the task is completed or not. So yes, let's give it. Just like this, empty with a collision marker. Then I want to convert it to the actual strings we want it. So each of the strings will be separated by color, just like this. Now I'm adding yes for true and no for false. Okay, so far we are first in the stages of a task from true or false to yes or no. You see here we have an error where they say the task completed is inaccessible due to the exploitation level, especially has to do with the fact that we have to make each of these variables public. And you can see the program has been corrected. So to avoid any of such error, we have to do the same for all of them. Okay, now we can proceed. So at this point, we are going to print out. So first, I'll do task ID. Okay, that's for the date format. And finally, we'll add the variable. Add it here. We'll create charity stitches. Okay, next we're going to add a short if statement. It will simply have to do with if a task list is empty or not. So we'll just have it like this. That is, if task list counts equals 0. We print out console, write line, no task, found, and breakout for a return. Now let's call it this here. So it matches what we have in our switch. And let's try and see if so far our code is correct. Okay, let's do the second choice, read task. We see we will have a small form. We call it date. It tells the date, isn't mentioned. So let's check that and let's try adding a task description. Let's call the task task 1. Date, let's say the day of the beast, Christmas Day. That's added. Now let's try reading task to see if your test has actually been added. It hasn't been added at all. So that's simply because at the end of our test, our add test function, we needed to add all of the new values to our central variables into the list. So here we have, just like this. Now with this done, we should have exactly the result expected. If you enter a choice, just add that directly to the description. You'll see. Okay, we have two tasks now, task 1 and C#12 project. But we have a problem at the date. It presents the year, the month, but the day isn't mentioned. And that, I don't know why. We're going to try correcting this. If you experience a similar program or something closer to this, you can simply modulate how you print the date. Just watch what I do. So here we have to open the date, the year, the month, and the day separately. Okay, right on mistake, because instead of a full stop here, we had a comma. So with this, we should have exactly what we want. So enter true space, get sum with test. Okay, we have 2024, March the 3rd. Fine. So we break out of this and move on to our last function implementation, which is the function mark as completed. So first thing we will do is to get the task ID from the user. Okay, so at this point we have our user giving us an input, and the input is supposed to correspond to the task ID. But the input we get from the user is always a string. But the task ID we need to use is an integer. So we have to convert this string input to an integer. And to do that, all we need to do is simply assign our int task ID, which is an integer. So this, which is the task, which is the input from the user. We can assign an integer to a string. So I have to convert it to an integer in this case. Exactly as you see, converts to int32 input word from the user. So once we have the input from the user, the next stop we have to take is to define the task to mark in the list. So create a new instance of task. Task.task2mark. So what it does is that, as you can read over here, it returns the first element that matches the condition defined by the specified predicate. And you found it will return it, otherwise the default value for the type. So basically that says you'll find the first value that matches our task ID, which is your name. If it doesn't find any, then it will just return the null value. And now I'm talking about the null value, we need to add in the condition for it, for if the task doesn't find any ID, which matches the task ID we have here. So that will be checking if the task is enough. So all that's done, we'll convert, is completed. Keep sure, console.writeLine. Here I have formatted string, which will simply say the task. The task ID has been completed. Just like this. Okay, so far I think we are done with implementation of each of our functions. Let's continue our code now to check if we don't have any error sticking around. So let's test our code. First we read the test. Fine, we have our initial test. We try adding the test once more, the test 1. Let's add it. One smallest with the first again. You see that 1, 2 just can even add a second task here. Let's go add a second task. Let's do it once more. We have 3 tasks. So now let's try marking a task as completed. That'll be 3. Enter a task ID. Let's say the task ID 3. That's 3 has been completed. Let's read them once more. As you can see, it's different. So with this, we can say our task manager functions well enough to understand what it does and know what we are doing at each stage. So that was it for creating of a basic task manager using the console app in the C# language. You see, with this mini project, we have learned how we have gone through a lot of the notions we saw earlier, basically which are the notions of printing out text, as well as taking text from the user. We also saw while loops, as well as if statements and other statements, and also we saw switch statements. In addition to all that, we also had a little glimpse into function creation, function calling, as well as class and method calling, without forgetting the list instance we have here, and the new data type we went through, which is the date, time, data type. So with that said, that was our console-based task manager. Thanks for watching, and we'll see you next time. Hi, and welcome to the next part of our C12 project, which is a task manager console app-based project. In this part, we're going to be implementing sorting. That is, we'll implement a function which will sort out a task depending on different criteria to be given by the user. So what we want in this case is that we'll like that once you've run this program and you're asked to give a choice here, and I'll give you the choice to and enter. After this task link being displayed, we would like to have the possibility to sort the list depending on different criteria. And the criteria would be the task ID, the description, due date, and status. So let's try to implement that into our code. The first thing we'll do is we'll move to the read task line and we'll add a few operations. So the first operation will be a prompt for the user to give an input for the sorting criteria. We are adding a bracket here, bracket open and close, so to include the searching criteria themselves. Okay, how are we going to change this to completed? Because it just makes sense to stay completed, yes or no, instead of status, yes or no. That doesn't make sense at all. I guess I'm making sense here. So next time we're going to assign the input button from the user to a new string, to a string value. The string value will be named sort by. Okay, then after getting the input from the user and assigning it to the sort by variable, we need to call the sorting function itself. So let's call that function sort task, and the argument will be the variable created earlier, which is solved just like this. Okay, let's move a little further and create a sort task function. So once the pass in our sort by parameter, you can add a few conditions to this. You add the condition to lower. What this to lower does is that it simply returns a copy of this string converted to lower cases. Because as you can see here, we have enter sorting criteria, and we tell the user to enter them in lower cases, as that is the same thing we're going to use in the switch cases. But in case the user accidentally adds one of them in capital letters, that shouldn't pose a problem to our code. So it runs smoothly and everything. So let's move to our first case, which will be the case of string ID. Okay, so from this point onward, we are going to do something a little bit cryptic. First, we have to sort through the task list. Then we will do the field conditions. But before that, I'd like to explain the sort method. So this sort method simply sorts elements in an entire given list, list T by default. Here our list is the task list over there, and it sorts them using a default compare. What's there is that given the parameter they add within these brackets here, you can change the default compare and also change what is being compared to it. So let's try implementing just that. First, we start by adding two parameters. So here, we're making use of the lambda expression, which is a concise way of defining an anonymous function. And this function will be used only within this task list sort. And will be used for the precise sorting criteria we're going to give here. Next on, we're going to make our element of type T, which is what we're comparing, to implement the iComparable interface, which will make us define the compare_to method, which is being used for comparison. So what we do is we simply compare. Okay, so basically this is it. I know this might look a little bit cryptic, but within the documentation, you should understand how it works. So basically what we've done is we've taken in two elements of type T, and we're returning an integer which indicates the relative order. So the integer is less than 0, or the integer is a negative value. Then the first element is less than a second. If the integer returned is 0, then the elements are equal, and when the integer is a positive value or greater than 0, then the first element is greater than the second element. This helps us a lot in sorting our function. And because what happens here is that by providing this lambda expression, And this sort of function knows how to compare the two tasks based on their IDs and sort the list accordingly in ascending order. So we'll repeat this for each of the cases, which will be description, due date, and the status respectively. Okay, so now we are done. With this, if we run our program, what we'll do is that what will happen is that the read task will prompt the user for the searching criteria, store that value, but we'll never return a new sorted list. So we want our program to not only prompt the user for searching a criteria, but as well return a sorted list. So we have to include that directly into our sort task function right here. Okay, so that display should look really similar to the display in the read task. We'll use the same, but a little bit different though. And finally, we'll have this for each loop, which will be the same as well. Okay, so this is how it works. Just fine. Let's go test it. Okay, first, let's do tasks. They're asking for searching criteria, the ID. We can't search it because it does one project, right? So add a few tasks here. So now we are going to try to read the task and solve them using some of the difference. Okay, now I have our 3 tasks. That's the C# tool project, which has the due date task 1. We have this one and task 2. It has this. So let's enter a sorting criteria. Let's sort it according to the ID in ascending order, which will have the same thing exactly. So 1, 2, 3. Next one, we'll sort it according to the description. Invalid choice. We want to submit the mistake in our program. We'll check that out. Now, don't insert this. No mistake. That's only because we excited the view task function once the sorting list was printed out. Okay, that's when my test manager wants more. Now you're ready for searching. So let's sort it according to description. You have the same description. That's simply because it is sorted in alphabetical order. And you have a C at the start. So fine. Then you have a task, but here's one, and ends here with 2 instead. So this is the right order. Next one, let's try sorting it with the due date. You see the order has changed. We have 1, 3, before 2. That's simply because here is earlier before the 2025 date, of course. Now let's try. If we sort it from according to the completed statuses, we will have the same thing because all of them are marked as uncompleted. So we are going to try declaring task. Let's see test 2 has completed. Then we'll try sorting out. Okay, you see we have no, yes. So the uncompleted app here first and the completed app here last. So we see our logic works well. The certain function is well grounded into our code and it works just fine. You see, even all these things are still before each of the functions are being run. It just adds a certain level of aesthetic to the code. So this, you can see our code is just fine. You can really try refining this code a bit more. So we'll invite you to like exercises using some of these operations we have seen throughout this project. By this level, for example, this list declaration here, the list declaration is fine. For instance, it's just fine for the code. But in case you liked to use this list in like throughout the code, it's not really advisable to declare it within the main method. But it will be better, like maybe out of the main method, like in the class program itself. Right here. There you have to add some identifiers, like making it public or internal. So you see the code is still correct. We haven't changed anything, but this simply makes it that if you have to declare another method within the class program, it will easily be accessible. Okay, so what's cool about C#12 is that once you create a project like this, like our project task manager, you can actually access that project from within the file system. So simply move to this location in your computer, which will be this place here. Then look at this. See all the system disk, then move to users and the specified user which you are using to work your project. So move here to source, repos. Here, it is my task manager. For my task manager, you see that we have our C# files program and task open bin debug.net 8. And here we have the executable file, which is my task manager. And running this file, you show exactly what we had while running it in the Visual Studio. For example, here, let's say we have exactly the same thing. So that will just show you that you can actually access the file and run them within your PC itself without having to open the code editor. So that was that for our project. I hope you learned a lot in this C# adventure. Thanks for watching, and I'll see you in the next modules of the course. Hello esteemed C# architects. Welcome to today's video entitled Principles of Object-Oriented Programming, where we embark on a journey into the heart of object-oriented programming in C#12. Okay, prepare to unveil the elegance, clarity, and flexibility that lies at the core of this fundamental programming design approach. Let's get started. Object-oriented programming transcends the limitations of procedural programming. Thus, you can imagine your program as a bustling city, not lines of code strung together, where each inhabitant, which we call objects in this case, possesses its own state. That is, thinking on its own personality and belongings, of course, and behavior. That is, its actions and communications. And these objects interact and collaborate, forming a dynamic tapestry of your software. So basically, that's to say, object-oriented programming is a programming paradigm that uses objects to design applications and computer programs. C# is a popular object-oriented programming language that fully supports all of its principles. Okay, let's dissect the pillars of this transformative paradigm. So in this part, we are going to explain some of the most commonly known and used object-oriented programming principles. First, I'm going to start with a class. Basically, a class is a blueprint for creating objects that defines the properties and methods that objects of that class will have. You can think of it like a template for building houses or perhaps even cars. All houses built from the same template will have the same basic structure, but individual houses might have different colors or any specific value attached. Next one, we have instances. An instance is simply an object, an individual object created from a class. It holds specific values for the properties defined in the class and can execute the class's method. Like a particular house built from the template, it exists in the real world and has its own unique characteristics. We move further to a lot of principles like polymorphism, which is simply the ability of objects of different classes to respond to the same method call in different ways based on their own implementation. That's like having different keys that open different doors, while the open door functionality is similar. So the specific mechanism depends on the key and the door type. That's just into parenthesis. Then have encapsulation, which is similar to bundling data or properties and operations that act on it within a single class. Basically, this functionality helps control access to data and ensures its integrity. You can think of it like a capsule containing medicine, perhaps. You know what's inside, like the general idea, but can't directly access it. You need to use a proper mechanism to interact with it safely. Then the final concept we're going to be touching here is inheritance. Inheritance simply allows you to create new classes or subclasses based on existing ones, which we'll call superclasses. The subclass inherits all the properties and methods from its superclass and can also add its own methods and properties as well. You can think of it as, imagine yourself building apartments based on your house template. The apartments inherit the basic structure, like the walls and roof, etc., but have their own layout and number of floors, for example. Okay, so far we've gone through most of the basic concepts or principles of object-oriented programming in C# as we know. We're going to go through the implementation in code as we move into this module. So next time, let's move to the benefits and potential of object-oriented programming. The first benefit we're going to be touching here is the fact that object-oriented programming empowers you to craft modular and maintainable code. You can think of it like Lego blocks for software. You can easily add them, remove them, and modify independent units. Next on, we have the enhanced code clarity and organization that comes with object-oriented programming. It simply helps you group related functionalities, like functionalities within objects, and keeping the program logic neatly compartmentalized. The next benefit we'll be touching here is the high visibility and efficiency of code using object-oriented programming. Thus, this programming paradigm helps us leverage inheritance and polymorphism that we explained earlier, and which helps us avoid coding redundancy across different objects throughout our code. And then finally, we have design flexibility and robust systems. Thus, the objects adapt and interact, allowing your program to respond dynamically to changing needs. Okay, that was that for the benefits of object-oriented programming. Throughout this module of our course, we are going to be experimenting with the diverse classes and exploring inheritance, as well as all the other concepts we mentioned earlier. What you have to remember is that object-oriented programming is not just a collection of tools. It's rather a mindset and a way of thinking about software that unlocks endless possibilities. So that was that for Principles of Object-Oriented Programming in the C# 12 course. Thanks for watching. Hello and welcome, C# architects, to the next part of our object-oriented programming, Myth Debunker, which is classes and instances or objects which we'll be talking about. So if you recall from the last video, we said C# classes are a blueprint for creating objects that define the properties, that is the data in it and the methods, meaning the behaviors of that object. So first we are going to create a class named animal, right here. And that our class is going to contain a few animal methods, basically common animals like dogs, cats, and ducks. And we're going to produce lines which speak out the sounds of each of these animals. So in our class, animal first, we start by creating a separate method for dog, then cat, and finally ducks. So we have successfully created our first method, which is the method dog, which seems to print the line woof woof, like the sound of a dog is going to make. We call our method void here simply because our method doesn't return anything. It seems to print this line and breaks. So I'm going to prepare this operation for the other two methods we'll be creating, which are namely the cat method and the duck method. Okay, so we have our class animals, which is the dog, which is what the cat, which is meow, and the duck, which is quack quack. So in order to implement this, we have to call our class, which is methods, in the main function right here. So what we do is simply type in for it to be accessible by the main method. We have to turn it into a public, just like this, adding the public keyword right here. I'm using a receiving wall. That's because our main method is a static method, so we have to quickly add that to each of our methods if we need to call them in main, just like this. Okay, voila. So now we have our animated.dev, which is correct. Let's try running this. You see we have our result. We have exactly as expected. So you can simply replicate that with each of our methods right here, which is good for the dog and for the cat as well. And just like this, voila. We have a work of mail and quite quick as expected. Okay, so far we have been working with creating classes, but we always did it in the same C# file as our program. But in order to avoid some confusion, let's say we make our code a bit less lengthy. We can create our class in a separate file, which we can call our main method in our main file right here, just like this. First, you type in Ctrl+W or Ctrl+S, depending on if your keyboard is an English keyboard or a French keyboard, or you simply go right here to View and you open the Solution Explorer. Once you have our Solution Explorer, try to enlarge this panel a little bit more. Okay, you see here we have our program file and some other stuff right here. So what we'll do is we'll right-click on my first app, then we'll go to Add, and we'll add a new item. The new item, the name should correspond to our class's name because we're going to add a class. Let's call it Animal exactly. Let's show the templates. So this is the first template here. It's a C# class template. That's exactly what we're going to use. Then we add. So this isn't a program at all. No, it's simply a class. I'm going to copy our class right here into the class file we've just created. Exactly like this. But in order to call our class animal from our program right here, what we need to do is we need to convert our class into a public class. So our main method will be able to read it from a secret file. Because as you can see here, it was an internal, and while if it's internal like this, you can call it from another file. In order for it to be possible, we need to render the class public, so it's callable from different files. So public, then we will make it public just like this. And as you can see, it's perfect. You can call it from here, and let's try running once more. And you can see we have the same result. Woof woof, meow, and quack. Okay, that was it for classes. So far we have seen how to create a class, how to call a class, both from the same CSV as well as from a separate CSV. Next one, we'll move to the instances or objects in C#. And as we said in the previous video, an instance is an individual object created from a class. It holds specific values for properties defined in the class, and it can execute the class's methods as well. So in this example, in our separate class, we're going to declare a few variables, which we're going to assign to values in our main method right here, using objects creation or instances for each of those. So let's go to that right now. Let's have at least a bow here. Let's say if it's alive. So bow, alive. Voila. So once we have these properties here, let's move on to our main web. So command this as well. So now we are going to create an instance for these variables declared right here. So the instance we're going to create to be an instance for a dog. A dog having, let's say we create an instance for Scooby-Doo. So let's say the name will be Scooby. The age will be, let's say 10 years old. Color. We'll give it a brown and alive. We'll say true. Let's create a new instance. So creating an instance is similar to declaring a variable, like declaring a variable with the data type being that secret class. Okay, first we'll name the class, which is the class animal. Then we have our object's name. Our object's name is, then Scooby-Doo will be equal to, we use a keyword new. Then we have our method's name once more, which is animal. We have the bucket open and close, then with the same code. So this is it. We have our new instance of the animal class, which is Scooby-Doo. Oh, let's change this instance. Instead of Scooby, let's give it dog. So we have a new instance dog for the animal class. So under dog now, so just like that, we're going to now assign each of the variables created in our class right here with the new instance of the class animal we created. So to do that, we are going to type in dog.name. Then we assign our dog.name. The string is Scooby. Let's move to our next variable, which is the 8. So far, we have declared each of the variables and assigned them to values. But you notice that our variable names here have these red squiggly lines on them. You simply tell us that they have errors, and when you hover over them, it says animal name is inaccessible due to its protection level. And that's simply because the variables we declared here, we didn't render them public. So basically, we can access them from our main method in the program file. So to remedy that, we copy. We're going to place a public right in front of each of our variables so we can access them from a circuit file. At this point, all of the errors are out of our way. Okay, if you run this program, you won't see any result printed, simply because we haven't got the values yet in a print function, if you could see. So in order to remedy that rule, we end up in a sentence. Okay, we just entered the statement. We shall have, hi, my name is Scooby-Doo. I'm the brown dog of age 10. We can toss in the cola. Voila. Up to arms seems quite known. Okay, hi, my name is Scooby. I am age 10. So you can repeat this for any other animal you'd like to create with these given variables right here, which we can declare in our class. So as you can see, the use of instances in coding in C# or in any other programming language helps in code modularity or code reusability, as we can use a single line of code right here in our animal class to create a really large number of animal instances. Anyway, that was it for objects and classes in C#12. Next time, we are going to be moving into the heart of object-oriented programming, which are the key concepts of inheritance, encapsulation, and polymorphism. That was objects and classes in the C#12 programming language. Hello esteemed C# architects and welcome. In this online video, we embark on a pivotal journey into the realm of inheritance, which is one of the fundamental pillars of object-oriented programming prepared to unlock the power of code, reusability, efficient design, and flexible hierarchies. Let's get started. Okay, imagine constructing a building. You wouldn't start from scratch each time you needed a window or a door, right? Instead, you leverage the blueprint and inheritance relationships to reuse common elements, while introducing specific variations to each of the designs. So C# inheritance follows the same principle. They allow you to create derived classes that inherit properties and behaviors from these classes. So this hierarchy simply sees that it's like a superclass, and that superclass can allow some other subclasses to inherit properties like methods. From then, so let's get to it. Okay, so in this video, we're going to use the same class dog created in our last tutorial. And in this class, we're going to name a few popular cartoon dogs we know, like Scooby-Doo. Then we'll name them. And then we're going to have a separate class, which is going to have their breeds in there. So in this case, the dog class will be supposed to inherit the breed properties from the breed classes for each of the dogs listed. So let's get to it. Okay, and in our class braid, we are going to have two specific braids, which will be the braid 1 and the braid 2 will be the Great Dane. Braid and the braid 2 will be the Beagle, which will be in separate methods, and each of them will say, like, I'm a Great Dane or I'm a Beagle. Let's do just that. So now we have created our parent class or superclass, which is a breed class. So now we're going to get into the subclass and adding the properties or the methods in it. So first, let's create the dog one. And this dog one will be Scooby-Doo the dog. Just like this. So let's repeat that for the second row. The second dog will be Scrappy-Doo from the Scooby-Doo cartoon. Then, dog 3 will be Snoopy the dog. Okay, with that, let's not forget our semicolons. Okay, so far so good. We have created our parent class and our child class, or our superclass and our subclass, which is the breed and the dog. So we want the dog class to inherit properties from the breed class. So we know that Scooby-Doo is a Great Dane as well as Scrappy-Doo. And then finally, Snoopy the dog is a White Beagle. But we don't want to go through the hassle of having to type back each of their breeds in their methods or do anything of that sort. We can simply link this class to this one. Properties directly in their methods, just like this. So the keywords make a class in the read properties from another class is to use in the column and writing in the name of the superclass, just like this. Now you see the dog class is related to the breed class, and it invoices all of the breed classes, properties, and methods. So now, with that said, we can simply call in the breed directly in here. Like you see, when we type in breed 1, it is one of the properties of our dog function in this class. You can add it directly in here, and it doesn't send us any error at all. But that's not what we are going to be doing here. We are going to move on to create an object or an instance from which we can call our method. So the first object we are going to create will be an instance of the we call the introduction of the dog one, which is, hi, my name is Scooby-Doo. Then we want Scooby to, let's say Scooby, Scooby dog, read 1, because Scooby is a good day, of course. Okay, so far so good. So let's run our program to see if it does what it's expected to do. And voila, it says exactly what it's supposed to say. Hi, I'm Scooby-Doo. I'm a good dame. So this console.read key right here, simply there to request a very familiar, but basically in this case, it just doesn't do anything at all. So it does not mind putting it or removing it. Okay, so we're going to do the same for each of our docs. So these console white lines, which go into a blank here, will simply make each of the results to be separated by a space or a blank line. Okay, we have our result. I am Scooby-Doo. I'm a Great Dane. Then next we have I am Scrappy-Doo. I am a Great Dane as well. And finally, I am Snoopy. I am a Beagle. Exactly as expected. So we see our dog class inherited all the methods from the breed class. So that simply makes it possible to inherit. You'll notice that if we simply remove this here, the code just isn't correct anymore because the breed isn't recognized in the dog class. Okay, another interesting property of inheritance in social programming is method overriding. So method overriding is all about inheriting a method and then replacing the content of that method by another in the new class. So let's see, for example, on the Snoopy. We don't want it to say, "Hi, I'm a beagle," but we want him to be more precise, like, "Hi, I'm a white beagle." So what we need to do is to override this. Do it over here. So we have our new sentence. So to do that, we have to render our doIt2 method virtual. So it makes it editable from other classes. Then from here, we'll repeat this method, but we change the content in it. Then voila. At this point, if we should run our program, we should have something like, "Hi, my name is Snoopy. I'm a white beagle." Exactly as expected. Okay, that was it for inheritance in C#12 object-oriented programming. This is simply one of the pillars of object-oriented programming in this programming language. So next time we will be talking on polymorphism and encapsulation in C#12. So stay tuned. This was inheritance in the C#12 course. Thanks for watching. Hi there, esteemed C# architects. Welcome today as we embark on a journey into the heart of polymorphism. Polymorphism is a cornerstone of object-oriented programming that empowers objects to respond dynamically to the same message in distinct ways. Essentially, this functionality allows objects of different classes to be treated as objects of a common base class. Prepare to unlock the potential for flexible, adaptable, and elegant software design. Let's dive in. Polymorphism in C#12 is achieved through method overriding, as we saw earlier with the inheritance video, and method overloading. Let's get straight to it. Here, you see we have our usual layout with the program.cs file right here. Then we adjust the adopt.cs file accordingly. With that said, what is method overloading? Method overloading allows multiple methods with the same name but different parameters to coexist within the same class. This enables the same method name to be used for different behaviors based on the number and types of parameters passed. Let's try something to illustrate this concept. In our program file, we'll create a separate class. In this class, we're going to have two methods bearing the same name but with different parameters. First, we have a public integer method. This public integer add method will simply take in two parameters, a and b, and sum them. We'll also have a second method which will still be public but will return a double this time. Here you see we have the same method name used twice, but they take in different parameters. The parameters are the same types but differ in data type. Let's try calling this right in our main method. Once we run this, we have 5 and 9.9, simply because 4.4 and 5.5 sum up to 9.9. In this example, the add method is overloaded with different parameter types, which are int and double, allowing the same method name to be used for addition with both integers and floating point numbers, providing flexibility and convenience. That was method overloading. Now let's return to our main topic, which is method overriding. Similarly to what we did in the previous video, we're going to have this public class dog right here, which has a method named intro that simply introduces the dog by saying, "I am a dog." From this dog class, with the method intro, we have a few other specific classes, each representing precise dog breeds, and from there, we'll have to override this introduction method provided in the dog class, just like this. Here we'll say Great Dane. We'll use the overriding keywords, which are virtual and override. Then we inherit from the dog class. Let's correct these indentations here. At this point, I'd like to create a few other classes for other dog breeds. Here I'll say, I'm a Great Dane dog. Now let's create classes for the Beagle and Chihuahua. So we have our parent class, which is dog, saying, I am a dog. Then we have subclasses like Great Dane saying, I am a Great Dane dog. Next, we have the Beagle class saying, I am a Beagle dog. And finally, the Chihuahua class, which will say, I am a Chihuahua dog. We'll now create instances of each of these classes in our main method right here. And these instances will perform the class's method individually. Here, we have instances for our three dog breeds. At this point, we could say Great Dane.intro. You see, we have I'm a Great Dane dog, I'm a Beagle, and I'm a Chihuahua dog as expected. But now, let's dive into what polymorphism itself is. As mentioned earlier, polymorphism allows objects of different classes to be treated as objects of a common base class. And what we'll try to do is run these 3 print statements using a for each loop. To treat these 3 objects as belonging to the same class, we'll initially declare an array of type beagle. Then we say beagle, open box bracket, close box bracket, beagles equals. Then we add beagle. If we add a Great Dane, you see it is completely underlined with squiggly lines, indicating an error, because the Great Dane method does not belong to the beagle class. Thus, it can't be identified as an object in an array of objects belonging to that class. The same issue arises if we add a chihuahua. So, if we want to iterate through an array containing these 3 dog breeds, we need a class under which they all exist, the dog class. If we change this to dog, open box bracket, close box bracket, all errors are corrected. We rename the array to dogs. We'll iterate through this with for each, open bracket, dog, dog in dogs, close bracket, and call dog.intro, open bracket, close bracket. Running this program should produce the expected results. I am a beagle dog, I am a Great Dane dog, and I am a Chihuahua dog. As you can see, the results we have here is what we expected, meaning that it works. This illustrates how, with the help of polymorphism, objects of different classes respond to the same method calls in their unique ways. That concludes our discussion on polymorphism in C#12. See you in the next chapter. Hi there, C# enthusiasts, and welcome to this new project on our C#12 adventure, which will be creating a student grid tracking console application. Similar to the first project, we simply created using the console app template. Okay, but the rest of the steps will be pretty much the same. This is our program clause in the student grade tracker console application. Let's change the first console height line to something different. Let's make it to be like the student grid tracker item. So we type in student grid tracker. Okay, just like this. But with this project, we'll need some additional class files, which will be the class grades and the student class. That will simply make our programming more efficient and more elaborate. That is going to ease our implementations of various types of functions. First, I want to create a new file here. Okay, so the model for our content, all the classes which will be included, which will be used for our program here. So first, we'll add the class grade. Then we are at the second class, which will simply be the class student. Okay, so you see that this time is of just placing the classes in. In the general file, we created a separate file named with models and placed those files into them. This simply helps in code organization while dealing with projects. So in case you have to work with too many classes, then it would be a good choice creating a file. Maybe different types of files depending on the types of classes which you'll be depending on. Okay, so let's meet the namespaces of these new classes accessible by our program class. Okay, so let's move to our grade class. In our grade class, I'm going to create 2 variables, which will be the variable subject and the variable grade. Here we use a getSet, so your value will not be easily modified. Let's add the public double this time. Double for the score. Then here we are going to add a constructor for our grade class. Okay, just like this. Okay, then listen to the student class. In this class, I want to create a variable, so it will be the student name variable and the student ID. Okay, so here we will first initialize the starting ID to be 1, then we will create a variable for the ID, and finally the variable for the name. Okay, then at this point, we create an instance of the list of containing the variables created in the project class here. We publish this. Great. GetSet equals to the new list. So you also have set, we set it to private set. So it's accessible only within the class. So it's a modifier only within the class and not out. Okay, then let's create a constructor for the variables we declared here. This line simply assigns the next ID and increments the counter to the student ID variable. There are more to do here, but at this level, we will leave it just like this. Now we will create a list of students here. Then in the main meter to add an infinite loop. So none of these functions have been initialized yet, but still to do that, turn off the switch. Switch to the cases based on the choice we have. The choices we are going to have on the getChoice function. Then from here, we have each of the individual cases. Okay, so now I'm going to create a function to display the menu options. And this function, we are to simply be a series of console write lines, simply printing each of the console options with greater enumerations. So you have a menu, simple. Since I like this to appear like on, with a line different from the student grid tracker, I'm going to add something which simply be a backslash n. You see it takes a different color. This simply makes the line to appear on a new line, basically. So copy this and go for each of the different menu. Then, with this done, we're going to add a function to get user choice, which will be the getChoice function. First, we pump the user for an input, then assign the input to the variable input just like this. Okay, so this input is a string, but we want to do the comparisons with integers instead. So we have to convert this string into an integer. First, we'll create a new integer instance, which will be integer choice. So integer, so actually this could work just well, but we can't always be with the user. What I mean by that is, if in this case the user inputs something like this, let's say dog, that dog string just can be passed into an integer because the dog doesn't contain any numerical character. So instead of doing this, we'll simply add a certain level of security to our code. Just like this. So here we'll see why, and see why the parsing is failed. So not integer, try parse. The graph was written here just like this. And one of our case is how the console printing invariant function, invariant input, enter an integer. So we have this. Then offer input once more, which will be cause the console hit line. Then out of our loop, we'll return the choice. Okay, so the return type of this function will be an integer and not a void. Let's run our program to see what we have done so far. Okay, promise enter choice. Let's say 3, we simply get back to the display menu because we haven't added any case scenario, but in case we get something like this, let's say dog, you see get invariant input please, enter an integer, invariant input please, enter an integer until you finally get 4, for example. Then we get back to the start, so provide a certain layer of error handling within our getChoice code. So we'll get more insight in error handling later in the course. Okay, so far we've created a basic UI of our student grade tracker console application, as well as our grade class and student class, which contain important parameters for the computation of the grade. Okay, we'll continue this in the next lecture. Hi there and welcome back to our Student Grade Tracker project. In this part of the project, we will be concentrating on initializing the functions on which our Grid Tracker console application will be running, and up until the end, ensure the smooth running of expected results. So let's get to it. On the display menu, you can guess the functions which will be needed in the switch. The first case is a student. Next, we have usernames and grade, and finally exit. So, go to the first function to be needed here, which will be this add student function. So what this function will do is that it's going to prompt the user for an input, a name input. You assign that name input to a string variable, precisely the variable we created back in the student class, the string name. Then after that, we'll fit the name into the student list, and it will tell the user the variable name has been added successfully. So let's get to it. Okay, next time we have the user lens meta. Okay, so far we have introduced the new student method. But there's something we have to notice right here. The issue is we don't have any formatted output for displaying the student alongside the student's name, alongside the ID, and perhaps the grade. So to do that, we're going to get back to our grade class and student class, and we'll add in another method. So here, instead of adding a method for displaying, we'll simply override the toString method, which is a vertical method in C#. So at this point, we are going to return a formatted string. It is simply say given subject equals to, has the given score. So let's have a look at that. So far, this is correct. But at the end of our program, all of the score entered by the user to be printed out in 2 decimal places. So to do that, we had a color at the end here, then it's F2. Don't get the wrong idea here, because this F2 doesn't mean the function 2 key on the keyboard or anything. It simply means 2 floating points. Like if I put F1 instead, then it will be a single floating point that we printed. So you'll have it. This is one of the newest ways of enhancing the display of floating point numbers in C#. So get to the students class and do an override the class method once more. But here it is displaying not only the subject and score, but here it will display instead the name, the student's name, the ID, and the grades that you take into account the overridden to string the idea. So in this method, what we will be displaying will be the student ID on the first line. Then the next line will have the student's name. Then the last line will have the overall grade, which will simply be the average or the mean of the grade in the various subjects we are going to add during the application's runtime. You have a method which we haven't initialized yet. That method is calculate overall average. We will do the colon and as well want it to 2 decimal places. So yeah, first thing we'll do a bit of an alternative, which accesses the grid values from the grid class. So let me just make that add grade. And you are talking 1.0 meter, which is the grid. So the add grade method will simply access particular grids from the grade list here. Then we get on to initializing and define and calculate overall grey matter. This part of the code will simply return the average of the scores in the grade class card. All right, just like this. This is good though. I would like to add an instance for the possibility that I earn any grade for a given student. So that should likely result to a returning 0. I'll give it to 2 decimal places as well. All right, we are done with the student class, as well as the grade class at this point. So first we have our title, then we iterate through the students list. So what this does is it simply will show the student list and it will print out the overridden true string formatted output, which defined by the meaning, the student ID name, and the overall grade, deepening on the number of subjects added. Okay, then let's add a few lines of code to handle the eventuality that the user checks for view students without adding any student prior to that. Okay, next in our series of functions to be added for the display menu to be useful is the add grade function. Okay, this is one of the most useful and actually complex methods within our series of methods here, because this method will require us to select the student from the students available, then you get the grade input from the user, and finally add the grade to the student. And the level of complexity within this function will require us to offer, so we do just that. We dissipate class within a space and add an input test in there. So let's do just that. This case we name our folder utilities. We won't add it to the same folder as the models because this isn't a model to our project, but the same player utility. Utility class and within the class, within the scope of this class. For a class we named input validation. Within the scope of this class, we will be testing the correctness of the type of input, precisely the name and the score taken from the user. Let's make this accessible to our program class. Okay, first we get to this part, where we implement our first function, which will be the isValid function. Okay, this function implements the validation logic for the name, like the same if the name is a string of empty spaces. So here we have our return. The first piece for this would be to check if the input is empty, and this condition will be to check if the input from the user are all letters. Alright, that's most of next week's video, isValid score. It will simply require the score to be between 0 and 100. Welcome back guys, let's proceed with our project. So what if the number of students is 0? If there are no students found, we'll ask to add a student before adding grades, then we return. Alright, now we move into our next part, which will be to select the student using their student ID. Alright, just like this, we initialize an integer, student index, which will be equal to the return value from our getStudentIndex function. Alright, so far we haven't initialized the getStudentIndex function yet. Let's do that before proceeding with the addGrade function. Okay, using a for loop, I'm going to display the student's name alongside their index. So for I meaning index, then I should be less than the student count, and it should be in incrementing. The for loop will return this, which will be the corresponding student index here with the name of the student. So in the programming, most programming languages will understand that the count starts from 0. It's always useful to set it as I plus 1 here. So we have student 1 is index 0 and student 2 is index 1. Alright, next I'll be prompting our user for the student's index. So let's give the user a range of numbers where the index will be found. Then you'll give it a 0, because that'll be the base value for the student count. So this is somehow a way of printing a given variable into a string. We don't actually format it, nor do we do string concatenation. Here instead, adding the curly braces, the variable is left at the end of the string. With the C# compiler, know that any string value contained in these curly braces here will have to do with this variable type right here. So they'll initialize that to a string, which will be the input from the user. Then we'll declare a new variable, an integer type variable, which will be named index. Okay, with the initialization done, to pass the inputs to the index. But here we'll do something a little bit tricky. What we'll do is we'll use a while loop, which will actually pass our input to an integer type value. But what this while loop is especially doing will be to erase all possibilities for the input taken from the user being invalid for this case. So the first case will be that the input is actually not passable. Just like that. Now the case where the index is less than 1. Then another case where the index is greater than the student count. And this will simply return a message to the user. Alright, just like that. Then our return value here will be the index minus 1. That's simply because we have to convert the 1-based selection as the student index starts with 1, convert it to a 0-based selection. And that's how it enumerates objects in the list. Let's proceed. Let's get back to our grade and continue there. So, that's what you'll need to get the grade details. First, we'll prompt the user for the grade. Let's initialize a variable. Let's reinitialize the variable for the score. So, next we're going to use a do-while loop. Okay, what this do-while loop will be doing is it will simply prompt the user for an input of the score. Then, it will read that score into an input variable and pass the input variable to the actual variable we have here as score and test if it fills the criteria for the score. For example, if it's possible into a double score, then it's likely a valid input. And finally, it will test it through the input valid score function we have here. And if it passes all those tests, then we'll break out of the loop. Else, what will we do? Alright, this will get interesting. Let's see if the pass is successful. We input our score like this. Then we have, and there, and it actually passes the validation test in the input validation class. Then we'll break out of the do-while loop. So this is when a valid score has been entered. Else the final part, but not the least of the addGrade function, will be to add the grade to the selected student. So here we will notify the user the grade has been added successfully. Alright, from our display menu, the last choice we've got there is exit. So we could just exit like letting it exit alone, but let's try implementing a clean exit function. Okay, so let's go to our switch cases. I think I'm going through all the instances for this. Now, let's run our code and see if each of the different characteristics we have implemented with various lines of code here will run smoothly as expected. Now let's test our program. Enter choice. Let's try to view student. You can see it says no students added yet. Now let's try add grade. All right, no students found. Please add a student before adding grades. Perfect. Next, let's try the exit if it works well as well. Okay, exit application, and we have actually broke out. And that should fix our code. Let's run it again. Okay, first I'm going to add students. So let's add John, we had Cherry Smith, and also Ron. I'm going to add grades to each of the students we created. But before that, let's view students to be sure our changes took effect. Okay, so there is ID 1, 2, and 3. Okay, fine. So let's add the grades. Let's include the mathematics grade, for example. Perhaps let's say John had a grade type score. So give him an 85 and repeat for the other students. Now let's view students. We have 85, 70, 95. So let's test our overall grade calculator function, which simply brings the average of different grades. So let's have a different subject, which will be English language in this case. Let's view the students once more. Here you can see we have the average of 55 and 85, which is 70. Average of 70 and 82, which will be 76. Then we have the average of 95 and 85, which will be 90. So our grade averages have been printed just as expected. And we can gladly say our function or our project, which is a student grade tracker, works perfectly as we expected it to. That was our student grade tracker project. The project is not bad. I would say it's even good as it is. You can add some interesting properties to this, like, for example, making the code print out grade characteristics like A, B, C, up to F for this course. That should be an exercise that you could test on your own to sharpen your C# programming skills. Okay guys, that was it for the Student Grade Tracker project in the C# 12 course. Thanks for your attention and see you in the next lectures. Hi there esteemed C# architects and welcome to Module 4 of our C# 12 course, where we will be exploring the main new features and syntax enhancements that have been introduced in this programming language. With the C# 12 update, a lot of features have been introduced which improve code readability, maintainability, and the developer experience. In this lesson, we will go through all of them and get started. So, let's start with primary constructors. Traditional constructors, as we used earlier in the course, explicitly define the logic for object initialization. However, this can lead to boilerplate code, especially when directly assigning constructor arguments in properties. We can see the introduction of primary constructors as a way to streamline this process. We're going to get into the syntax and break down the logic of this new syntax enhancement. This code snippet displayed on the screen right here shows a class student with two public variables, which are name and age. Then we have a traditional constructor for the student's name and age. This is exactly how we've been doing it, but we can see this way of doing things is somewhat verbose. What the primary constructor is all about is, first of all, the property initializers. Let's create a primary constructor here. At this point, opening the curly braces and adding the properties will simply initialize these properties directly using a lambda. Look at how we've really compressed this code into a single line. Primary constructors help us make the code more readable and actually more efficient to understand and implement. Let's comment this out. You may ask, when should you use primary constructors? Primary constructors are ideal for use with properties that are using only the get. They can be directly initialized using primary constructors as there's no need for separate setters. They feature automatic property initializers. As long as all the properties of automatic property initializers or the get and set, the primary constructor with parameter names matching the properties can be used for concise initialization. Some things to consider while working with primary constructors include that there's no control flow. That's simply because primary constructors lack traditional constructor bodies, as you can see here in the traditional constructor. So, complex or logic or conditional assignments need alternative approaches, like separate methods. Then you have the base class constructor, meaning if your class is inherited from a base class with a constructor, you will need to call the base constructor explicitly within the primary constructor. To better demonstrate the base class constructor, let's create a new class here. Let's call it class activity for the student's club activities. Okay, so let's inherit the student class in our activity class. To counter this error, I'm going to add a constructor to take in 3 parameters: the name, the age, and the club. At this level, we can implicitly redeclare these variables, but we'll simply call the initializers for the base class by using the base keyword. Then this other club initializer, just like that. So you see this here, that's only because our student constructor isn't made public. And that's it. And if you want, no matter which code it is, if you want to see what also happens here, the activity class inherits from the student class, and the primary constructor calls the base class constructor right here to initialize the inherited properties, which are the name and the age from the student. And finally, it assigns the club parameter to its corresponding property. So that was that for primary constructors. Next, I'm going to move collection enhancements in C#. This is another syntax improvement in the C# language, which is mainly centered around collections such as arrays and tuples. For example, so let's get to the first one. This collection expression for initialization, which is mainly implementing direct collection initialization for inline arrays. Okay, so this is a typical array declaration right here with a list of numbers from 1 to 11. Basically, these are prime numbers. To implement inline arrays here for this list, this is how we'll do it. The difference is that here we won't need these brackets. We'll simply add the characters immediately. I can copy our list just like this, and you can see that we don't report any error. It's simply correct. So this is it. We can further shorten this initialization. So list, left arrow, int, right arrow, type list of numbers. This time, and here we'll give equals, put a square bracket, and in the square bracket, you have the same thing. Okay, so it will be your choice, choosing which one you like. Perhaps you'd like the traditional or the simplified or the further simplified with the square brackets. But what you have to note is that printing each of these should give the same result. We'll give a for each. Okay, so you have 1, 2, 3, 5, 7, and 11. We change these to list instead. The list, which is right here, that should also run correctly. Okay, so you see our tool is actually syntactically correct and logically correct as well. So we're moving to our next feature, our next new feature in C# 12. So the parameter we'll be looking at next are the reference read only parameters. The traditional ref parameters allow modifications of the original data passed to the method. However, sometimes you only need to read data without actually carrying out any modifications. So the ref only parameters address this by providing a reference to data, but ensuring it can't be modified within the method. This improves code safety and clarity. Let's go work that out and see how it's implemented in C#. Okay, so let's initialize a method here. It should be a void method, execute method, and the text in the parameter, which is of an integer type, name number. Okay, so what the method simply does is it prints the number which it takes as a parameter, and then it increments it. We've seen this number wouldn't be leading us to anywhere once the function is run. I don't think the implementation should change anything, but let's just leave it there for the sake of this example. Outside of our method, we will declare a new variable. Let's name the variable myNumber this time. MyNumber will be, say, equals to 32. Then we'll call our print function, which will be printing myNumber this time. Let me try one. Okay, we have 32. This is as expected. Then let's add a simple console printing of myNumber variable, just like this. I want this. This should simply give 32 and 32. All right. So Using reference values, that's for writing our integer, any number, into a reference. Let's call this a reference value. Let's let this be a reference as well, so we don't have an error. If we run this time, we should get 32 and 33. So that's simply because once the code is run, once that my number is slapped into the function, then it's printed 32, but it's finally incremented. And once it's incremented, that value now goes down to the next line, which gives 33 instead of 32. So to make sure we don't have such by mistake, you can make the reference read-only. So you can see by turning this variable into a read-only type, we've got an error here. So that simply shows that it isn't permitted at all. But some of the benefits of read-only are that it improves code safety as it prevents accidental modifications of data passed. Also, we have enhanced readability and potential performance benefits as, in some cases, the compiler can optimize code using reference with only parameters due to the immutability within the code. So you may be asking, when should you use a read-only reference value? So you might use it when you need to access data passed by reference, but you don't intend to modify it within the method. Also, you can use them for scenarios where data immutability improves code clarity and reduces the risk of unintended side effects. Some additional considerations to take while using read-only parameters is that they cannot be used with primitives like integers or strings because they are already passed by value. They are primarily used with reference types like objects or arrays. Let's move to the next one, which will be the default lambda parameters. So, you have default lambda parameters. Traditional lambda requires all defined parameters to be provided when calling the lambda. This can be limiting if some parameters have default values, unfortunately. So, a default lambda parameter allows defining optional parameters with defaults, and this means you can call the lambda with fewer arguments, and the missing ones will use the predefined defaults. So, getting back to our task manager project, we move to the task, the class task. Now we have our constructor right here. Right now, I'm going to modify this constructor into a public constructor, a primary constructor. But before that, you see that in this constructor, we have 3 parameters, and one which is default, which is the isComplete parameter. So making use of default lambda, we're going to try to emulate this. Then let's add the original variable, and then finally, we're adding its default lambda. As you can see, we've successfully set the computed default to false, as expected during our project. So that was all for the default lambda parameters. Some other features we will talk about during this lesson are the alias any type, which helps in providing a shorter and more descriptive name for some complex generic types, which can be lengthy and repetitive to write. And this feature helps improve code readability and maintainability when working with complex generics as a traditional approach to define names and types, or the C# version creates a type alias for a given complex type. Okay, so far we've gone through the main and the most useful, in our opinion, key features and syntax enhancement from the C#12. We'll end here for this lecture and continue in the next lecture. See you then. Hi there, and welcome esteemed C# architects to our introduction to the world of error handling. Throughout this module, we'll be discussing errors and exceptions handling in C#12, its key concepts and best practices. Let's delve into error handling and best practices. Errors in C# can be defined as unexpected conditions that disrupt program flow. For example, attempting to divide an integer by 0, which is not possible because the computer can't perform such a calculation. Exceptions are objects thrown by the CLR, Common Language Runtime, to signal errors. Let's showcase a simple example demonstrating errors and exceptions. From a look at this code, we have an initialized integer, num, which is 0, and the result simply is the division or the quotient result from dividing 10 by the num. We then print out the result. Running this, we already know which error we're going to get, but alright, this is what we call an exception. An exception locates the error and forces you to handle it before program execution can continue. We have the exception handler system.divideBy0 exception. This is the name of our exception right here, divide by 0 exception. It prints out all the exception types apart from divide by 0. notably the format exception, which is the error during string formatting operations. Then we have the argument exception, which occurs when an incorrect argument is passed into a method. We also have the null reference exception when you attempt to use a null reference. Finally, we will talk about the index out of range exception, which occurs when you try accessing an element outside the collection bound. From this simple example, you see how the C# compiler presents the errors, maybe the exception, and the location of the exception in our code. But we need to handle the exceptions as if it's a real application. We won't be printing out error messages, nor will the compiler be printing out error messages to the program users. That's where exception handling comes in. We're going to talk about the try-catch blocks, which are fundamental mechanisms for handling exceptions, and they come in this format. In the try block, you place the piece of code that is susceptible to produce an error or exception. For example, this piece of code right here. We're going to cut it and place it into our try block just like this. Then in the catch block, you specify what should be done, perhaps a print message or any other action. With the try-catch block, at least we are sure that we won't have a break during our execution, as the error will be handled nevertheless. Like in this case, if division by 0 occurs, it prints a message saying cannot divide by 0. Right, you see, just like this, cannot divide by 0. Or else, if we change our number from 0 to, let's say, 5. Okay, we have our result 2 as expected. So you see, the try-catch block prevents breaking out of execution as we effectively handle our error or exception. Alright, that was the example of using the try-catch block. It's usually more advisable to be more precise with the error we should handle. For example, we know already it is a divide by 0 exception. So we can set our catch block to catch just the divide by 0 exception. Now we name the exception X, just like this. Let's close all the categories over here. Then finally, we can print a message to the user directly. We set it back to 0. We should have a print message from the divide by 0 exception. Okay, attempted to divide by 0, exactly what we did. Alright, that was for catching specific exceptions using the try-catch block. Next, we're going to demonstrate how to catch multiple exception types using a chain of catch blocks. Let's edit our code that's here. Alright, so this piece of code simply takes an input from the user and passes it into an integer type. You can see where the errors here can come easily. For example, if the user intends to insert 3 and types E instead, we'll get an error and an exception message immediately, which will be a format exception. Let's try catching a format exception like format exception. Then we'll get the same thing, x.message. Now let's see how it works. Alright, now to show our code was perfect, let's try giving it an exception and let's say 5. The input string 5 was not in the correct format. So this is the exception message for the format exception. Alright, let's add a level of complexity to our piece of code by initiating a division by another integer. So right here, we can anticipate another error. So we can get a catch and the error is simply divided by 0 error or divided by 0, except you'll get another catch block with pretty much the same thing right here. And then finally, just for best practices, we add a last level or an additional catch block, or in case we get an exception which we didn't anticipate. Maybe you could just tell the user something like an unexpected error has occurred. So this last line isn't compulsory at all, as a code will run fine without it. Also, if you successfully anticipate all the possible exceptions which may occur from a piece of code, you're fine. But it's always good to have a certain level of security proof on your codes. So, in case you may have missed an error or an exception, the last level is going to catch it. Okay, so let's give it a 0 here. The number is 0, and then you have an error because you attempted to divide by 0. So you see this is a block of code you can catch either by using the format exception or the divide by 0 exception, and in case we miss one, we have a last catch which will get it for us. Alright, that was that for try-catch blocks. In summary, you can see you can use try-catch blocks to handle potential exceptions gracefully. You can choose specific exception types for targeted handling as well. Next time we are going to be creating custom exceptions for application-specific errors. I will consider using assertion creators for advanced control. So basically, we'll be using the throw statement in exception handling. Alright, That was it for handling errors and exceptions using try-catch blocks along with best practices. Hello, esteemed C# architects, and welcome to the error and exception handling part of our C# 12 course. Throughout this video, we'll be talking about exception handling, specifically the use of the throw statement. The throw statement can be defined as a mechanism for explicitly throwing an exception object in a piece of code. Its usage within methods or code blocks is mainly to signal error conditions. Let's have a look at that by creating a separate method which permits us to divide two numbers. We'll call this method divide safely, and it will take into two parameters, which are the numerator and the denominator, labeled as A and B. This method should simply return the result of the numerator, A, divided by the denominator, B. As we know in common division, if the denominator is 0, the division won't be possible. To counter that error, we are going to use the throw statement. We will anticipate our exception, then counter it directly within our code. First, we have an if statement. So if b equals 0, we'll throw a divide by 0 exception with an explicit message, the denominator cannot be 0. Alright, let's call our divide safely method within the main method with the parameters 4 and 0 for the denominator. This should trigger a divide by 0 exception during execution. But instead of having the normal print message given by the C# interpreter, we should instigate this as the denominator cannot be 0, as expected. The throw statement, as I mentioned earlier, explicitly throws an exception object. We notice its usage must be coupled with the correct exception from the given error. For example, here we use a divide by 0 exception because we have a divide by 0. If we had inserted a format error here, we wouldn't have the correct instance. It's very important to throw the appropriate exception type for accurate error handling. So far, we've had a glance and overview of the throw statement. Now I'm going to get into creating custom exceptions using the throw statement. An exception is very similar to a method. Actually, it's a method that interrupts code and prints out a message. First, I'm going to create a new exception, which will be an invalid age exception. That will be an exception that validates an age given a certain range. First, we'll have our method class, which will be a public class called invalidAge. This class is going to inherit from the exception class, and then from here, we'll have our exception itself, which will be public, and the name will be the same. The parameter will be a string message. Then from here, we'll have our actual age validation method, which will be a public static. And this will simply be if age is less than 18, then we'll have to throw our customized exception, which is the invalid age exception right here, which will say user must be 18 or above. This is how to create an exception or customize an exception for a given piece of code you need. And I'd like to emphasize that it's always good, once you create a custom exception, to have a sounding and informative message to accompany it, so that the user will be able to understand it as easily as possible. So far, we have seen how to throw built-in exceptions, like in the case of divide by 0 exception, and also how to create custom exceptions. In the previous video, we also saw the catching of thrown exceptions, that is, catching precise exceptions and not exceptions in general on a given piece of code. You might be asking when to throw exceptions, and there are plenty of scenarios where thrown exceptions are essential for robust error handling. Some of them include invalid user input, like when negative values or letters are entered when numbers are expected. Then we have resource access failure, like not finding a given file or network errors, as well as internal programming logic, or unexpected conditions such as the divide by 0 we saw earlier. It's recommended to avoid throwing exceptions for trivial validation checks. It's easier to use return values or out parameters. And some best practices we show include throwing exceptions with clear and informative messages, like what we have right here. To conclude, we can say the throw statement is one of those key words in the C# language you shouldn't play games with, as you will hardly do without an exception handling. And as I mentioned earlier, the use of appropriate exceptions in your try-catch blocks, as well as in your throwing statement, is of paramount importance. Guys, that was that for the throw statement in the C# 12 error and exception handling. Thanks for watching. Alright guys, now we are going to look at file input-output handling. That is, how to provide some text input to or from your file, which is very important. When you push it through the program, you are going to realize that you might write a program related to file handling. That is, you are going to need to write text into your file and read text from a file. So I want you to pay attention to this. The first thing we are going to do is add the namespace using system.io. To do that, we use the namespace for input output. All right. Okay. So the first thing here is we are going to create a variable that is going to specify the path of our file. So I'm going to create a variable file path of type string. And yes, in my file explorer, you can see that I've created the C# folder, which is going to contain the file. From here, I can directly copy the address of the folder and paste it here. So for file paths, we don't use backward slashes, rather we use forward slashes. We need to put it in quotes and end with a semicolon. Okay, so here I'll change all of these to forward slashes for the path to be valid. Now I'm going to write the name of our file, so we can name it example.txt, because we want to create a text file. So in the folder, if you want to alter a file, you write the name of that file. But if you want to create the file, then we can as well create the file using this method. So this is going to create a file of type text with name example in the C# folder. I'm going to create a string for the content, which is going to hold the text you want to save. So hello world, for example. Let's keep it simple and basic. All right. Now we are going to use the file class. As you can see, we already have a suggestion here of what to do by pressing the tab key. It will fill the code for us. A file is a class that provides static methods for creating, copying, deleting, moving, and opening a single file. Here we are using the writeAllText method to write text. It has two parameters. The first parameter is the file path, which is the path of the file to which the text will be written in, and the second parameter is the content, which is what we want to write into the file. So if I run the code, you can see that it ran successfully. Now, when we open the File Explorer, we can see that a text file has been created, and when we open it, you can see the content says, "Hello World." All right, it works as expected. Now let's see how we can read from files. I'll close this and this as well. Let's remove this for now. And to read, what I'm simply going to do is assign to this variable a method from the file class, and that method is readAllText, which is going to read all the text from this file path and assign the content of the file to this variable content. We are going to write this content to the screen, displaying it on the console. So remember, we had previously created the file using writeAllText. Now we are going to read the content of that file and display it on the console. When I run the code, we have this. As you can see here, we can say hello world, which is the content of the file. We previously created the file, and you can see here that the content of the file is hello world. So that would be it. This was just a basic overview of file reading and writing. Next, we're going to see how to do that using streams in a safer method and a more professional way. See you in the next lecture. Alright guys, in this lecture, we are going to discuss streams and I/O. In the previous lecture, we covered the system I/O namespace, which is essential. This namespace is crucial because it includes streams, which are used for reading and writing input and output from files. For example, you have file streams and memory streams, which are used to read and write data from memory. You also have network streams, which deal with connections and also handle sessions. But here we are going to focus mainly on file streams because we are dealing with file handling. In the previous lecture, we saw how to handle reading and writing all text. These methods are very straightforward and simple to use. However, if we want more control over our reading and writing operations, such as when you want to read or write a file line by line, then we are going to use streams because they provide more control and flexibility for reading. And writing to files, they are part of the system I/O namespace and are typically used within a using statement to ensure proper resource management. So we are going to see how that is done. So here we have this code. So we have the stream writer here, which you can see is a class that is used to create and write streams of text into files. So here we are going to create an object of this StreamWriter class, which I'll refer to as writer. Remember from what we discussed about classes previously. We create an object writer of type StreamWriter, and here you pass the file path parameter, which is the path to which the text will be written. Remember the file we created recently? So here we are going to write all this text to that file. As you can notice, this is included in a using statement. We do it this way because we want to ensure that when we're done using them, the resources are released. This is to ensure efficient resource management. All right, so as you can see, remember in previous examples, we wrote a bunch of data all at once, but here we have much more control. Using this WriteLine method, for example, we can just write this line, then follow it by another line. We have flexibility. We can write just one part of the code or text to that file at a moment. You can handle different parts of the file separately. It doesn't all have to be done at once as a chunk. So here, for example, you write first, hello world. And then we have another line here that writes, this is a second line. So I can go ahead and demonstrate this. And let's see what it produces. Let's go to our file and see how it turned out. If I drag this here and open our file, all right, so you can see it says hello world. This is a second line, so you can see it works perfectly. Now that is the stream writer. You can also work with stream reader. Let's close this. So I'm going to get it ready. All right, as you can see, we create a stream reader object, which is a class used to read characters from a file. You can see that it accepts the file path as parameter. Remember, all of this is included in this using statements to ensure that all these resources are released because it has to do with memory and system resources. So we make sure that they are released after we have finished reading or writing to or from our file. All right, so here we create a variable line which will be used to read the document line by line. Then we have a readLine method. So while this line, we use the readLine method, which is used to read a line from the document. You can see that here, it reads a line of characters from the current stream and returns the data as a string. Okay, we pass these characters to the line variable. As long as the line we read here is transmitted to this variable, and as long as that value is not null, that is, not an empty text document, then we are going to print that line. We then have the WriteLine method, which is used to write specific string values. As long as there's no character, and then we keep on reading the line and writing it. We read a line, we write it. So we read the line, we write it, read it. So here, for example, you might get confused because if there is a space character, then this is not null because even a space or new line character is going to be read. If I do this, this is not empty. And this is a new line character there. Whereas when I reach here at the end, there's no more content after that. So let that not confuse you. We just deal with null when the file has been gone through completely and no character is left. Now, let's run the code. You all can see clearly that we have hello world. This is a second line. So this does the same job as what we have seen previously, but it is more appropriate to use because it is more flexible. And when we work with large files, for example, we might want to use this for more efficiency as well. So we have talked about everything on file handling. Now let's see how we can also do it safely using exception handling. All right, for example, let me copy this. Okay, we have this. So we are going to have our file path, and you can see I've altered this to example2. You can see that we have no such file in our file explorer. I have intentionally written example2 to demonstrate how to handle file input-output related exceptions. Here we are going to attempt to read the file. Remember, when we did exception handling, we are going to write this in a try block. And what we do is we create a text variable of type string, which is going to store all this text. So we are going to read the text and pass it to this variable. Then we print the text. So here we can have some exceptions, such as file not found exception. That is an attempt to access the file that does not exist in the given file path. So this is when we don't find the file. In this case, we'll notify the user with file not found. Also, for example, some files, as you know, can be protected by the operating system, and access cannot be granted due to security. So in that case, we are going to have access denied, and for every other exception that occurs, we are simply going to inform the user that an input-output error occurred. And we are going to use this to print a message. This exception message is going to be printed to the user for him to know what exactly is wrong. So this is very useful, as it's not just going to make the code crash, but it's going to notify the user that a certain error occurred. And from there, the user will know what to do next. So when I run this, here's what we have. You can see it says file not found, and that is because there's no file with this name in our given directory. So that would be it. And from there, the user can know what to do later and then maybe he'll try to access a more appropriate file. So this is going to be all about exception handling and about file management. Now you can write into files and also read from files, all of that in a safe way. You can use this read all text or write all text when dealing with small files, when doing something very easy and straightforward. Whereas if you want to do something more large and complex, more flexible, you are going to use the stream reader and the stream writer. Also, remember, it's good to do it in a way that promotes safety, such as exception handling. In this box here, you can also see the list of exceptions related to I/O handling. So, that's it for this lecture. See you in the next one. Hello C# architects, and welcome to the language integrated query part of our C# 12 course, which is the module 7 of the course. So throughout this module 7, we'll be talking about LINQ right here, or language integrated query, by defining its certain benefits, which is what we'll do in this video. And then we'll talk about its main operations, operators, and how we can use it in real life projects. So let's get into video 7.1, LINQ and its benefits. All right. So first question is, what is LINQ? You may ask. As I said earlier, LINQ stands for Language Integrated Query and is a powerful set of extensions in C# that provides a unified syntax for querying various data sources. So what this simply says is that LINQ is a set of operators and operations that simplify data querying or data accessing from various sources. So this functionality backs up some challenges or traditional data manipulation in the C# language, as it offers a declarative approach. That is, it focuses more on what the programmer wants to achieve instead of how to achieve it. So basically, what this means is that once your master LINQ, its operations and operators, you can directly focus on what you want to achieve from programming instead of trying to wrap it around the background logic necessary to achieve or to query for data from various sources. All right, let's move directly to the next slide, which is basically the benefits of LINQ in programming. So the first benefit that we'll be listing is the improved code readability and maintainability. As you can see in our code example here, LINQ is very clean, concise, and easy to understand. Basically, the code declares a list of numbers. Numbers are basically odd numbers. Then we declare a new list, which is even numbers, which will be like a LINQ filter featuring even numbers from these numbers. So the list even numbers, the numbers within the numbers list, and then test operation number divided by 2. If it's equal to 0, if it by the list, it takes it to the new list, and then we can iterate it and print it. But from this code, you can see there are no even numbers here, so the result will probably be nothing at all. Next one, we have type safety as LINQ. You enforce type checking throughout the query and reduces errors. Then we have flexibility, basically saying that LINQ works for various data sources. For example, here we have the list being created by the user. You can access various data sources like XML files from which you could read data directly. And finally, we have powerful extension methods. Aside from the .where extension, here we have a lot more extension methods as well as operations which are possible with LINQ. All right, with all that said, you might ask, what about C# 12? Are there any new, say, benefits or operations added with the C# 12 language? Unfortunately, the C# 12 doesn't introduce any major changes to LINQ itself, but it is an object because the overall improvements brought about with the C# 12, like pattern, matching, and switch expressions, for example, can potentially further enhance code with ability and maintainability when used alongside language integrated queries. All right, Next on this module, we'll be diving into the LINQ methods and how to use them in real-life projects. That was all for LINQ and his benefits. Thanks for watching. Hello, esteemed C# architects, and welcome back to the LINQ part of our C# course. In this lesson, we'll be discussing the core concepts of LINQ in C#, which include two fundamental functions, the where and select. We'll explore how these functions help us filter and transform data. Additionally, we'll cover the aggregation functions, such as sum, average, and count, which allows us to summarize data collections into single values. Lastly, we will look at other functions. Let's dive into the LINQ core concepts. First, let's discuss the filtering operations, particularly the where function in LINQ. This function selects elements from a collection based on a specific condition and makes use of lambda expressions to define the filtering criteria. For example, if you have a list of integers from 0 to 100 and want to fill all numbers greater than 50, traditionally you would use if or else if loops. However, with LINQ, you can use the where clause, which simplifies the process. To demonstrate, let's filter the numbers using the where clause. We'll create a variable, filtered numbers, which will store all numbers from the list that are greater than 50. We can then iterate through this variable to print out each number. If we run this code, it should print 75 and 98, exactly as expected. Next, let's discuss about projection using the select clause, which transforms elements from a collection into a new format or data structure, and is also commonly used to create new sequences with desired information from the collection. For instance, let's consider a hypothetical list of students with names and ages. Let's comment all this. We have the scribbling lines here because the IDE doesn't recognize the data type. To fix that, let's create a class student with properties name and age. So, let's suppose from this hypothetical list of students with their ages, we want to extract the students' names based on a given criterion for age. From this, we aim to extract the names, not the ages. Alright, assuming we use this hypothetical student list with their student name and ages listed, and we want to extract just their student names. To do that, we need to make use of the select operator. Similar to filtering, I'm going to create a new variable of type var. So, that'll be equal to student. Select. And once more, we'll iterate through the students' names. Alright, and running this, we should have printed John, Jerry, and Alice. Alright, good. Just as expected. That's it for the select clause. Now, suppose we want to extract just the names of adult students, i.e. students over 18. This allows us to filter the students by age and then select their names for display. Firstly, I'll change these ages here to 17 and 19. We can use the select operator combined with the where clause to achieve this. Let's see how to combine the select clause and the where clause. We can filter students older than 18 and display just their names. First, we need to change this variable to adult students' names. Then we have the code. We add the where clause. So here, we'll have a where, then here, we'll have a dot. With this configuration, we can pass the where clause and follow it with a select. So, we filter the students and then select a given criteria or a type of data to display to the user. With this setup, as we are filtering the students with ages greater than 18, we will display just their names. So, running this should display John and Alice. Alright, we get just that, John and Alice. That's how to combine the select clause and the where clause. Next, we will explore the aggregation functions, which include sum, average, and count. These functions perform calculations on an entire collection of elements, allowing you to summarize data collections into single values. So let's take a look at how they are implemented in C#. Alright, we're going to use the same list of integers we used previously in the filtering to test the sum, average, and count functions. In this list of integers, we have numbers ranging from 0 to about 100. There are 7 of them, and the sum as well as the average are unknown. First, we'll initialize a data type, which can be any data type that supports integers. You can use an int as well as a decimal or a float, depending on the type of result you may have. For the sum, we're going to use int here. So, say int total sum, just like this. But actually, we were supposed to use the student list instead. All right, I'm uncommenting this list over here. We are going to compute the total sum as the sum of ages here instead from the student list. So you have the students just like this. Similarly, the summation should simply be the sum of these three integers over here. Voila, exactly. Now let's move on to the average. The average will be kind of the same thing, but we'll be using the average keyword. Let's convert this from integer to double because the average function takes the double as data type. Now, here we should get the average of the ages, which is 18.666666, as shown here. Then we have the count, which simply counts the number of elements in a given list or a given database. So the counting returns an integer type as you will be counting integers. Let's say int student count, and that will simply be equal to students.count, open bracket, close bracket, which is the count function right here. I'm printing this out. All right, you see we have 56, 18.66, and 3 names. That's good. Those were for aggregation. Believe me, there are many other things you could do with this list, but this is the basis you should know. Finally, we'll discuss the ordering functions, which sort elements into a collection based on a specific property or criteria. The order by function sorts elements in ascending order, while the order by descending function sorts them in descending order. Let me remove this here, as it is not necessary. Now, let's print the sorted list. As you can see, we have Alice, Cherry, and John. Let's see another example. For instance, we can order student ages into descending order. All right, here's the code. It shows 20, 19, and 17, which is the ages sorted in descending order. That covers the basic core concepts of LINQ in C#. Be sure to practice these concepts to familiarize yourself better with LINQ in C#. Thank you for following along with LINQ core concepts. See you in the next lecture. Hi there, esteemed C# architects, and welcome to this part of our LINQ adventure, where we are simply going to apply all that we have studied so far on LINQ to our student grade tracker console application. So, in order to work with LINQ operations, the first thing we need to do is make the namespace accessible to our code by adding using system.linq, just like this. All right, so now we're good to go. All right, let's start by using the select operator, and for that, we're going to be making changes in the viewStudents method. So for this method, you see we simply call the formatted output we created in our student class right here. But we won't oblige using this, like overriding the toString method. We could have simply generated a formatted output right here in the viewStudents method, just like this. All right, so this part will remain pretty much the same thing. But here at this level, I'm going to add a new variable. We'll have a type variable, a variable with the name of the student information or student info, and that student info will simply be equal to the formatted string of the student. Okay, so we'll assign the student here to our return output from the formatted toString method. All right, then iterating through each of the students should give us the same result we have when we call the viewStudent function in student info. So you see, we've completely changed our program, and the formatted toString method here in this case is close to useless. So this is how you can make use of the select operator using LINQ in C# in every project this time. All right, so next one, let's go test the where operator by adding a new function or a new method, which will simply be a method findStudentByName. As the name indicates, the method will help us search through the list of students and find them, giving the input when the user matches the name inserted in the database. So for instance, for there being no students in the list of students at all. Okay, now let's get to our logic. Then we'll define a variable matchStudents, and this variable will go through the list of students, if there are any, as we've said here, and take the name given by the user, that's the search name matches the name in the list, or any of the names in the list. So here we'll get students.where.when, where the student name equals the search name, we get the value and pass it to the variable matchStudents. That's it. Now let's use conditional statements to model our output in case a match is found. So you'll have this: if my student matches the search name, then we format the output using a for each loop like this one. I'm going to say no student found with that name. Okay, that was a clean method. Let's move to one more method, which is going to help us search other LINQ operators we haven't had the opportunity to see yet. So let's create a method or function to calculate the general statistics of the student's grade. Let's call it calculate statistics method. Let's overwrite our general case in case student count is 0. Then let's initialize a variable to calculate the total students. Next, let's have a variable to calculate the average grade of all the students should be a double, which will simply be the average of the overall grades of all the students. Then lastly, let's have a variable which simply is outputting the top student or the student with the highest grade. So this will be type student. Then this will be sorted by descending order since we want to have the top student at the top of the list. So we simply order the overall grade of the student by descending order of merit. Okay, if we leave this, we have all the students printed. We want just the first student, that's the top student, to be printed, so we'll get a first or default such that we'll have just one student printed at the end of this operator. Okay, that's good. We have our 3 variables initialized. Now, let's actually print the interface of our statistics calculator. Then you simply print out the total number of students as well as the average class grade or the average student grade. So here we'll have the top student and the grade on top. Then the next line, we'll have the top student actual name, then his actual grade. This could go well, but we have to add an instance for a case where perhaps all the students entered haven't had their grades inserted yet, because if we leave like this, we probably have some chaotic results at this level. So let's add an if statement. So if there's actually a top student, that is, if top student is not null, we have our output as expected here, else we'll print this output, which is no students found. It may sound a little bit redundant, but it will make all sense once we run the code. So that's good. Okay, let's add our newly initialized functions to the code runtime. So let's add a few other cases. All right, now we can run our code. Let me enter to view students. As you can see, it says no student added. Let's add a few students. All right, now, once more, let's view the students. Okay, we have ID1, ID2, ID3, John, Ron, and Cherry. The respective scores are 60, 89, and 76. This time, we'll just add one subject. So now let's try to search for a student. For that, we select option 4, enter a student name. Let's say Bob. No student found with Bob as the name, exactly as expected. Now, let's try something else. Let's save the student once more. Let's say John. There's a small letter instead. No student found with John as the name. So we could add a little more accuracy to this, such as it recognizes small letter cases and upper letter cases. But this is just it for now. We'll actually take Ron this time. Okay, found student, Ron, found. All right, so let's set this to 2 floating points as well. Rather, let's set this one to 2 floating point. Oh, we didn't declare this was a method here, and also we didn't add the floating points either. So that explains the error. With this correction, the code should run just smoothly. Okay, so once more, we are back at it with the same values. Let's go through the statistics and see if we corrected the errors as expected. All right, fine. So here we have it. Top student, Ron, overall grade, 89, just as expected. So the display isn't the best, but we have the result we wanted. That was that for working with LINQ in C#12 in a real project. You can exercise yourself by adding a supplementary function for maybe finding a student by grades or something like that. That was it for now. See you in the next lecture. Alright guys, welcome to this lecture in which we are going to debut with graphical user interface design. We are going to learn how to build a graphical user interface application using WinForms, a shorthand for Windows Forms, which is a set of extensive libraries offered by .NET for producing graphical user interface applications. This tool is very useful as it allows us to program applications without writing much code. I'm going to show you how that is done. The first thing you have to do here is create a new project. So I'm going to do this. Make sure you select desktop app and all platforms. You can then select this. Okay, so I can name it WinForms App 2. Then you click on Create Project. Okay, so right now the project is being created. All right, you can see it is waiting for IntelliSense to finish initializing. You can continue working. So from here, we can open the Solution Explorer while the designer is loading. All right, so within WinForms, it's done. So this Solution Explorer is used to navigate between all items in the solution. Another thing we need to add is the toolbox. The toolbox is going to be displayed this way. It has all the components we are going to need to create an application. All right, so here is the designer. Let me resize these. All right, I'm going to resize this window like this. Also, we are going to need the properties window, so we'll add it. Okay, so using WinForms is very easy because you have this design window, which allows us to create an application without writing code. For example, let me show you. Let's say we want to add a button to our application. All we have to do is come to this toolbox, search for the button component, then drag the button, and place it wherever you want. All right, you can see we have our button, and that's it. So actually, we place it anywhere we want on the screen. Let's say I'll just place it here. And here, in this property window, it displays the properties of this selected component. If I select the button, you can see it says button1 system.windows.button. So this is the path. And here, if I select this, it changes to form 1. This object has been selected, and these are its properties. So let's go ahead with the button and let me show you how to read the properties of a component. Here we have the ways of arranging the properties. This first one here is categorized where related properties are grouped together. And if I choose this one, the properties are going to be in alphabetical order, as you can see. So we can leave it to categorize. Okay, so this is the label of the button. For example, I can change this text to click me. And when I hit enter, you can see the text has changed to click me. So when I leave this button, it is going to look something like this. This is what our application will look like. All right, we can close the app here. We can maximize it, or we can't minimize it. And when we open the application, the button is going to appear here, exactly at this position. So in the designing phase, you can scale to resize this button, just like this. Just like this, as you can see, I increase its width and height. Also, there are a lot of properties here. For example, we have properties that are related to the appearance of the button. Here we can maybe, by choosing this, change the font of the text. That is the font of the click me text in there. And if I press this, I can change its color. You can see the color, it changes to this. Okay, so there are a lot of other custom colors. Let's take this one, or rather, let's select a sharp color like red. You can see that the color has changed to red. Here, we also have the border style. So there are a lot of these properties. Actually, what I want you to know is that when I select a different property, you can see that the text in here changes to tell you what is the use of the selected property. And here we can see this property indicates the appearance and behavior of the border and title bar of the form. So you can see because this form is being selected right now. Whereas if I do this and select the button and select this property, you can see it says that this property indicates whether the component should draw right to left for RTL languages. So by reading this property description here, you can know what the property is all about, because I can't go over all these properties to tell you what they do. And also, each component has its property. You can see that we have a lot of them in the toolbox. So we can't go through all of them. Here, the best way is for you to learn how to use these properties. For that, you just have to learn how to read the properties descriptions and also how to set it. One important property is visibility. We have it here, visible. So when this visible is turned to true, when we run the application, we are going to see the button, whereas maybe, for some reason or the other, we have to see how the application behaves, and without the components, then we can simply turn this to false. And this is not going to be visible when we run the application. So as we proceed in further lectures, we are going to look at more properties. Then you'll get used to them. So for now, I'll advise you to explore these properties on your own. You'll also find out that they are fun to play with. For example, here we have the background color of the button. When I do this, you can see it changes to green. So you can really customize it to your taste and easily without writing code. And the good thing is we have the code here. In here, we are going to write like event handlers code. For example, what is going to happen when we click the button? We are going to see that in further lectures, but not now. So here, you just design your app and the code is also generated for you. So I'm going to remove this for the moment. I'll delete it just like that. And it is gone. All right. So for this form here, I want to change that to something like Notepad, because our project is to design a Note app that works similar to the Notepad application you have on your machine, just like using WinForms offered to us by .NET. So we are going to end here for this lecture. And in the next lecture, we are going to start developing our Note app. See you then. All right, everyone. We have started our application, and the next thing we need to do is we are going to create a menu bar with menu items just like this one here. To do that, we are going to type in the search bar, menu. Let me select this menu strip. You can just double click it. By clicking it, you can see it appears here because it is not something you can directly drag and as a single component. First, I'm going to create a file menu just like the one we have here. So next to it, I'll add the edit menu. And after that, we're going to have format. So this is just to show you how it is done. I'm not really going to add all of these menus here. So it's just about the basics, so you understand how it works. You can realize, for example, here in this menu, we have many items such as new, open. For the scope of this course, we can't cover these ones. Also, you can see under these as well, we have another options menu under add. For example, we have new project, existing websites, etc. So we can reproduce this cascading in our app as well. You can see we can have a menu item and a submenu item. Here I'm going to have something like new to create a new file. Here I'm going to have open, and after that we're going to have save. And then save as. All right, so you can add so many items if you wish, but I'm going to stick to these. Let's concentrate on this file menu for the moment. All right, so here, let me show you something. I'll just close this Solution Explorer for now. All right, so yeah, we have the properties, and here we have the events. And you can see what should happen when an event occurs concerning this component. For example, if you click, if you double click, or if you're scrolling through the form, it defines what is happening. So you can state which action is going to happen if you double click or click on this file object, for example. So we can give it a name here. The easiest way to define it, for example, by double clicking, we are going to be sent to the part of the code which handles the event for this object. And here you can see we have a method that is an event handler. So this method is an event handler that describes, for example, when we click what is going to happen. When we click that, what you want to happen when you click new is that we want the new file to be opened, and for a new file to be open, the text area has to be emptied. Oh, sorry, I forgot to add the text area. To do that, we have to find the text box. I'm going to add this text box here. Okay, text box here is an area where the user can input text. For example, we have this little space here, and the user can type anything. For our app, we need this area to fill this whole space, just like this. Here, for example, this coding area can be considered as a text box because you can write code anywhere you want. So I'm going to come here, and I want this to cover the whole window. How am I going to do it? I'm going to come here to the properties. We have this particular property, dock. Okay, so you can see, for example, I can decide to dock in this way. It's going to span the upper side of the window. And if I want to do it this way, then it is going to, okay, it doesn't fill this because this is just a single line. For us to be able to make it fill the whole window, you have to make it multi-line. So you can see here, a multi-line is set to false. As you can see here, you can control that the text of the edit control can span at more than one line. So right now, we can add only one line worth of text. I'm going to come here, then I'll change this to true so you can see it has adjusted and now it's somehow attached to our frame thanks to the dock property. You can see, for example, when I drag the frame, the text area is also expanded. So we have that, and to this text box also have a niche functionality. You can add a scroll bar just like this one. So we are going to come into its properties and look for it. To easily find it, I'm going to sort this alphabetically. Okay, scroll bar, we are going to add a scroll bar. This is a scroll bar, a vertical scroll bar. So I'm going to choose a vertical scroll bar here. You can see we can now have a vertical scroll bar, and if the text is much, then we can scroll down to see the whole text. And if you want, you can add a horizontal scroll bar or maybe both. It's all up to you. So when the text is going to be much, the scroll bar is going to appear. I'm going to leave it to vertical. All right. So now that we have done that, I'll double click to get the event handler. What is going to happen is that here you can see that the name of the text box is textbox1. You can see it right here, textbox1. So you can change your name here in this property. I showed you how to do that in the previous lecture. You can change your name here, but I'm going to leave it this way. So when the user clicks new file, what we want to do is that it is going to textbox1, right? Clear, which is going to clear all the text in the text area. Okay, so this text box is going to be cleared and the text area is going to be left empty. I can now run the code and show you how it functions. All right, we have it here, so you can see we have our Notepad app. Here's the title, and you can see that when we hover a menu element, the color changes to red. And that is because it is set like that in the properties. You can see it. So I'm sure if you go, when I select this, you can see that the fore color is set to the red when it is hovered. So you can change it back to black. I'll just leave it this way because it is kind of stylish. So you can see we have new, open, save, save as. For the moment, it's only new that's working. You can also expand this. And in here, you can write some text in this text area. Hello world, for example. And when I click new, it is all cleared. Using the clear method we have here, so it clears everything that is in the text box. All right. So we are going to end here for this lecture. And in the next lecture, we are going to see how to add code for the event handlers to these menu items here under the file menu. See you in the next lecture. All right, everyone. We are going to proceed by enhancing the open menu. First, let me remove these. Okay, so I'm going to double click and another window will appear where you will refer to a method with the event handler that is going to handle the open menu item. Before we proceed, we need to add the open file dialog box. So up here, you can see open dialog 1, and an open dialog is just like this. For example, when I press open, let me go to open a folder and then open folder. This is a dialog box. This open dialog box can let you select a folder among other options. We have the title here, select folder. And here you can choose a folder, then click on select folder to open it. All right, so here's the name. We are not going to change the name. You can change it if you want, but we are mostly interested in the method here. All right, let's proceed to the code. This is the code you're going to use to handle the open menu item. So, in this method area, you have an if statement. The first thing is, you have the name of the dialog box, open dialog 1, and here we have a show dialog method, which is used to display the dialog box. If it returns dialog result OK, that is, if the user clicks OK in the dialog box, otherwise it can return cancel. So we are going to now see if this method checks and the returned result is OK. So this is OK when the user clicks, selects the file and presses the OK button, right? It's going to return dialog result.ok, which is, as you can see, a Boolean value of 1. Then, this if statement, we have a try block. So that's where you're going to run the code safely. And here we are going to read the contents of the file into a stream. So we create a variable that we will call file stream. And this open dialog box has a method called openFile, which is going to open the selected file. So it opens the file selected by the user. All right, when we open this file, we read its content into this variable file stream. With the help of the using statement, we use the stream reader. We have seen that previously when talking about file input-output handling a few videos ago. Here we have file stream. We are going to read this file into a reader, which is a stream reader object. Now we are going to display the content in the box, in the text box. To do that, we are going to set textbox.text. This text represents the content of the text box. So we are going to read the content of the file to the end. Read to end is a method that reads all characters from the current position to the end of the stream. So let's read the text content found in this reader object. So we read the content object from the beginning to the end, which is the content of the file, and transfer that to paste it in the text box. All right. And now in the catch block, we have in case of an exception, it is going to return an error. So in case there's an error, it is going to display error. Could not read file from disk. Original error. Then we have this method we have seen previously, which is going to be used to explain this exception error. It is going to get the message that describes the current exception so that the user can understand what is exactly going on. We can run the code now. So we have this. All right, if I press open, you can see we have this dialog box that will open, and we can, from here, open a file. Okay, we are already in documents. For example, you can see I can open this C# folder. You remember we created this file previously. So it says, hello world, this is the second line. And now we press new, and a new file has been created. So far, it is working well. Now let's look at how to add event handlers to save as and the save menu items. Okay, I'll close this and this as well. So I'm going to come here, and we are going to begin with save as first before we go to save, and you'll understand why in a few minutes. So when I come to save as, I have. Okay, we need first to use the save file dialog. We are going to add the save file dialog, which is the dialog box that's going to appear when you want to save your file. All right, so you can see everything is okay now. We don't have errors in our code anymore. All right, so here in this method, what happens is we use this filter, which as you can read, gets to set the current file name, filter string, which determines the choices that appear in the save as file type. Okay, so if you read this, it can be confusing. Let me show you directly. When you come to file here, for example, we have save as, all right? So yeah, you can see what you have here is save as type. You have all the files. Notice here in the brackets. The extension, and you have text files, and here you can see the extension. So this is the same thing we have here. You can see text files of text type, and there we have the extension. Then we have this standing slash. And we have all the files followed by the generalized extension. We are going to have something similar to this when we run our code. So this filter is used to help you set the type of file you want to save. So now in here, we have an if. So this if checks if the dialog box returns OK. That's, for example, you've clicked on save. So previously, when we were working with to open a file, we had the same thing. And in that case, when you click open, it's going to result to OK. So here, when we click save, for example, then this code is in here. This if block is going to be triggered. And what it simply does is that it's going to create an object of type stream writer. And we are going to get the save file dialog.file name. So this file name is a file directory. So this will be the name of the file that we have chosen. This file name is selected in the file dialog box. We have a default value. The default value is an empty string. So this is the default value, but when we select the file, it gives us the file name of the selected file. And in that file name, obviously, the file path is included. So when you do this, you identify the file name and the file path if you prefer. But as you can see, we have a default file name with a pre-selected directory. And when you click on Save, we use the write method to write the current content of this text box to the file, with the help of the writer to the file that we are saving. All right, that's it for Save As file. Let's proceed to Save before we run the code. All right, so first I'm going to create a new variable in our class here. I'm going to call it. First, it's going to be a private variable of type string. I'm going to call it current file path with an initial value of null. It's going to store the path of our current file. As you can notice here, we give a value of null for now. We then come to the design part to create an event handler method. Now we have the code. So what happens here is that we are going to check if the current file path is null or empty. So this method is going to check if the value of this string is not null. So remember, we initially set it to null. So if it is null, then we can call this save as method we created above. Then it is going to call save as, and in that case, if the file doesn't have a path, that has never been saved. Then we are going to save it for the first time. Whereas if there is already a file path that's there, is a location in the memory of your computer where it is already saved. Then we are just going to update the content of the file with that of the text box without having to choose the file name again. So this is done using this StreamWriter class. Just as we did above, we create a StreamWriter object and we pass the current file path, which is the path of our file. Then we write the content of the text box to that file. And by doing that, you have updated the content of the file. So that is it. And before I run the code to show you how it works, let's do some few things. So remember, I recreated a new file. So we also want that whenever we create a new file, we set the current path file to null. So that when we are saving, if it is a new file, we are going to call the save as method, even if there was a previous file path in the memory. So this is going to make that every time we press on new, the current file path is going to be considered, and it's going to have a null value. Then when saving, the save as method is going to be called. All right. And also in the open tools method, we are going to make sure that, okay, so every time that we open a file, we are going to check its file path. We have open dialog.filename. So every time we open a new file, we are going to set the current file path to the file path of this file. So that in case you want to save it, after the very first time, it is not going to ask the file path again because the file path is already memory and it's just going to access it and proceed by updating the value of the file. So we are going to do the same here. After saving, as we update the current file path in memory, so current file path equals 2, you have this. If save file dialog 1.filename. Okay, so now let's run our code. Okay, so we have it here. We have our application here, and we have a new file. And for example, if I say, hello, this is the new file. If I want to save this for the first time, I'm going to press save as. However, if we are saving it for the first time, there's no previous file path. So even if I click on save, it will call the save as method, and you can see the save as method is called. Remember, the text filter that we use to set the file type here is it. And I can choose this, for example. Let's say example 2. We are saving it as text file. So I can now save. Let's add the content. I have added text. All right. And yeah, if I press save, you can see it is simply saved without asking for any file path. So I'm going to click new, then I'll open example 2. You can see it updated and saved our file successfully. So we are done with the file menu. We can now create a new file, open a file, save or save as to save the file for the first time. So that's it for this lecture. We are done with the file menu items. In the next lecture, we are going to see how to add functionality to the other menus. See you in the next lecture. All right, guys, we have already completed the file menu. And in this lecture, we will concentrate on the edit and the format menu. So I'm not going to add options. So let's jump straight into adding a few things like copy to copy the text in the text box. Also, we want to add cut to copy and clear the text area. Then we can add paste to paste copied or cut text. And lastly, we can add something like select all to highlight all of the code in the text area. All right, so those are the options we are going to add to the edit menu. Now, let's add the code or the event handlers to these menu items. It is very easy. All you have to do is use the text box. So for copy, we have the full stop, copy, open bracket, close bracket method. It is already a defined method in C#, so all we have to do is to call it when the user clicks on copy. All it's going to do is copy the entire text in the text box. We are going to do the same thing for cut. Text box 1, full stop, cut, open bracket, close bracket, which will cut the text into the text area. All right. Next, we have paste. Text box 1, full stop, paste, open bracket, close bracket, which is going to paste the content of the clipboard into the text area. And then for select all, you double click and we do the same as in the previous one. Text box 1 dot select all, open bracket, close bracket, full stop. So as you can see, the edit menu is set. That was pretty easy because all of the functions we have chosen are already defined. So we just had to call them. Now, let's add a few options to the format menu in order to style the text in our text area. We can add something like font. Okay, let me set font style to style the font, and here we can have font color. Okay, for these ones, we're going to need tools such as the font dialog. So we're going to need one dialog for the font, and we are also going to need a color dialog. Now, let's get to the coding part. So here I'm going to double click this, and here we have the code for changing the font style. So here you have the dialog box. This will be used to choose the appropriate setting for the font, such as the type of the font and making the text bold. This line here checks the result of the dialog. If it has been pressed to OK, then it will return OK. We can also assume the value is true for Boolean. So if that is true, then we set these settings to the text in the text area. So guys, let's proceed now to the font color item. As you can see, the code is almost the same. In this case, we use the text box .for color, which sets the foreground color of the text. We have the color dialog and the color. The color of the text area will be set to the color selected by the user. All right, that's all. I can run the code now. All right, here we have it. We are going to open a file. I choose to open an example 2. Now let's see if our app works as expected. Let's select all the text. Okay, it works. You can cut it and paste it as well. Everything functions as intended. So if I select all, I copy and paste. Okay, each of the options functions as intended. So now let's select all and format the text. Okay, here you can see the font dialog. There are a lot of options. Maybe you can choose to strike out the text. It's going to show you a sample of what the selected option will look like before you select it. Let's underline the text and remove this strikeout. Here you can choose the font type. There are a lot of them. I'll just choose this, and here we have the font style. You can make it bold or oblique, for example, and you can as well change the size of the text. Then we hit OK. You can see our text has been formatted. So I can now select all of these. I'll show you how you can change the color. This is the color dialog, and we have a gradation of colors from which we can choose from. As you can see, the default color is black. We also have white, but that won't be readable. So I'll choose this. Okay. You can see the color has changed, but it is not very clear. So I'll change it to something different. As well, custom colors which offer a greater list of colors to choose from. You can either scroll through here or enter a color code using the RGB format. I'll just select this red. Here you can see the formatting is done just as we intended it to be done. So we're going to end here for the Note app. We have created the file menu and also these menu items here. We've seen how we can add event handlers to each of these menu items and the code logic behind them. You did the same for the edit menu and the format menu, and everything is working perfectly as intended. So we are going to wrap this lecture on the GUI development using WinForms. As you have seen, there are countless possibilities of what you can do with all the tools you've seen in this toolbox here. As you can see, we have the properties of each tool that can be directly dragged and dropped into our design form. And also, weave the description to all the properties of each tool, which will help and guide you. Give life to your imagination by using these tools here to create amazing GUI applications. By practicing and also writing the code on your own, you will clear all of the doubts you might be having right now. See you in the next lecture. Alright guys, we are now going to delve into development using ASP.NET Core. Let's explore what this framework is all about. ASP.NET Core is a powerful and flexible web development framework that allows developers to build modern, cloud-based, internet-connected applications, such as web apps, Internet of Things applications, and mobile backends. It is the open source version of ASP.NET, developed by Microsoft and the community. Throughout this series of upcoming lectures, we will develop a web application using this framework, which is a very powerful and useful tool. ASP.NET Core is incredibly flexible for developing web applications. One of the key features is that it's a cross-platform framework, which allows it to run on Windows, Linux, and Mac OS. This makes it a versatile choice for developing web applications that need to operate across different operating systems. This is a powerful feature because you can write code that runs across various systems. It also greatly enhances performance because ASP.NET Core is designed for performance. Its modular nature allows for applications to include only the necessary features, often resulting in leaner, faster applications. For example, in the application we are going to develop, you'll realize that most of the groundwork is already done, and you don't really need to write or emphasize on a lot of them. It deals efficiently with that performance part, so you can easily learn and write applications. Also, it is an open source framework, which has a vibrant community of contributors that ensures continual improvement and updates to the technology. Alright, now that's a basic overview of ASP.NET Core. Next, we will see the requirements needed to develop a web application. We are going to need an ASP.NET environment, which you can set up on Visual Studio or Visual Studio Code. Personally, I prefer Visual Studio Code, just a matter of preference. We will set it up in the next lecture. Then you are going to need a basic knowledge of C#, which you already have if you have followed through the previous lectures. Additionally, an understanding of HTML and CSS and knowledge of Bootstrap will be a plus. We will also need JavaScript knowledge to manage the web events. This is going to be the back-end language that connects you to the front end. Don't worry if you don't master these languages, as we are going to step through the development process step by step with detailed explanations, and it will look much easier than it seems. Alright, this is the application that we are going to develop a to-do list app. It is a web application hosted locally on this machine. For example, you have a list of items to do, like go to school, then cook, and when you're done with them, you can delete or update them. For instance, if you want to update this, you can simply click Update and change it to something like Cook this evening. Alright, and when you hit Enter, it will update and save the item. If you want to add a new one, you can simply type something like Meditate and add it to the list. So, that is as basic as that. Maybe after you come back from school, then you decide to delete Go to School. You can see the list is still visible and the object has been deleted. We are going to learn how to develop this using C# and what happens in the backend, most importantly. Also, we will use HTML and CSS for the basic styling. This is just a basic app, and we are going to dive deeper into studying it. See you in the next lecture where we will set up our development environment. Hello guys, and welcome to this lecture. In this session, we will set up our development environment for the to-do list app. As previously mentioned, I'm going to use Visual Studio Code for this project, which is just a matter of preference. You can also do this with Visual Studio. Let's get started. You can download Visual Studio Code from code.visualstudio.com. There you can find a version compatible with Windows, Linux, and Mac OS. For Windows, you can directly download system installers and then proceed with the setup, which should match your requirements. Once you've set up correctly, since we've already downloaded the SDK, then there's no more left to do. When you open Visual Studio Code, you'll see a welcome page. The first thing you'll have to do is to install some extension. You can find these by using the search bar. You'll need the .NET Core SDK extension to manage different versions of the .NET SDK and runtime. Additionally, you'll need the official C# extension from Microsoft to write C# code. After installing these extensions, you're ready to start. I've already created a folder and opened it in Visual Studio Code's Explorer, where all our project files will reside. To do this, you can simply come to File, then to Open a folder, and navigate the file path where you want to store your project files. Next, open the terminal within Visual Studio Code. Here, you can see I've navigated to the folder, but I'll be storing the project files. We're going to run a command to create an MVC application. Type .NET new MVC and name the application to do. When you hit enter, it will create the basic code structure needed for our application. Back in our project folder, you can see the code structure. This pre-existing code saves us from writing all of it from scratch and sets up the essential framework for interacting with the web browser. There's one more step before we can run our application. Open your commands palette. For Windows or Linux, use Ctrl+Shift+P. For macOS, use Command+Shift+P. You'll need to generate assets for building and debugging. In some cases, a notification will pop up here asking you to do that. All you've to do then is to click on OK. If that's not the case, then you can search it here in the command palette and click on it to proceed. Mine is already done, so I don't need to do it again. Now, let's run the application without debugging to see what it looks like initially. I'll select this and this. OK. Here you can see our basic website hosted locally, with the MVC file structure managing everything. We have a basic web page titled To Do, with home and privacy links, and here we have a welcoming page and a footer down here. This is a link that will direct you to a page that will help you learn about building web apps with ASP.NET Core. So, I strongly advise you to click on it and learn some basic concepts. We'll end here for now. See you in the next lecture. Hello everyone. In this lecture, we are going to discuss the codes found in these files and their functions. Let's begin with the controllers folder, which contains classes that handle incoming browser requests. Controllers process incoming requests, handle user input and interactions, and execute appropriate application logic. The home controller, for instance, is responsible for loading initial views. The modules folder contains classes that represent the data of the applications and logic to govern this data. This is the central place for defining data structures, business logic, and validation. Then we have the object folder, which has more to do with debugging. Here we have some codes, but let's skip this as it is not of interest for now. Then we have the views folder, contains templates or HTML files that generate the user interface. These files predominantly use Razor syntax, which allows C# code to be embedded into HTML markup. Typically, there's a folder for each controller, for example, home, and within these, there are .cshtml files for each action of the controller. There's also a shared folder for layouts and partial views. For example, we have the privacy and the index.cshtml, which is the view loaded by the default action of home controller. If we come here, we can see a controller method responsible for the return of this view. Let me show you. So here you can see the view returned by the privacy file, and in here is the index page, which are all Razor views. Now, let's look at the www.root folder, which contains all static files, like CSS and JavaScript, essential for the front end, and Bootstrap as well. Remember, I told you we are going to use Bootstrap to style our web app. This is also where you'd store external libraries and images. Finally, the app settings.json file contains configurations data, such as connection strings and application settings crucial for connecting to databases. This file is passed at runtime to configure the application. Then we have the program.cs file, contains the entry point of the application, setting up the .NET core HTTP request pipeline. For example, it sets up a host for the web application and configures services and the app's request handling pipeline. As we customize our application, we'll modify these files to fit our specification needs, such as adding new pages, updating routes, and enhancing functionality with additional services. In this project, we are not going to include an error view module, as I'm not going to include an error page in the project. So I'm going to delete the unnecessary files now, starting with this error view. Additionally, the privacy page isn't needed for our to-do list app, so I'll remove that as well. Remember, our models here are designed to represent the data of the application and the logic that governs this data. Since we've removed the error page, you might be wondering what a view model actually is. Typically, a view model is a type of object that contains properties for all the information we want to display. An error view model, for example, would contain properties that help display error messages. However, since we're removing it, we'll replace it with our functional model related to the to-do list. I'm creating our first functional model now. Here we have the to-do item module. I'll rename this model to better reflect its purpose. By pressing F2, I rename this model to to-do-item.cs. This to-do item model will hold the properties of our to-do list items which we will display, such as the ID name. Each to-do item will have an ID name and a name. These are defined as public integers and strings, with getters and setters included. That covers the changes to our model. Now, let's adjust our controller to reflect these updates. Heading over to our controller, since each method corresponds to a view page, and once we've removed the privacy and error pages, I'll also remove these methods from the controller. For now, we'll only keep the index method, which interacts with our main page, the index page. Looking at the layout, which contains the HTML and CSS references, remember I mentioned we'd need a bit of Bootstrap. While the generated code from the template is useful, we will customize it for our needs. I'm going to clean up all this, including the header and footer, as they aren't needed. This will simplify our page layout, focusing only on the essential elements. The container class provided by Bootstrap defines the page's styling. It's crucial to understand how Bootstrap classes work, although we won't delve deeply into Bootstrap in this course. I'll keep the container as it is. The render body method in our layout is essential. It's where the content from other views will be rendered when you navigate to different pages within the application. This method ensures that while you can switch to different pages, the layout components like headers and footers remain consistent across the site. It's crucial for displaying content dynamically within the set layout structure. With our environment now streamlined, we're ready to start writing code in our next session. It might seem overwhelming at first with all these new concepts, but with practice, it will become more manageable. So don't just watch me do it, but follow my steps as you will understand better by doing. Also, by the end of the project, you'll be familiar with all of these concepts, so don't worry yourself if you don't understand everything now. See you in the next lecture. Alright guys, today we are going to proceed by creating the layout and form for our application. If you've previously followed along, you might have noticed a typo or error in the controller, which I've addressed and made necessary changes. So, you should fix that as well. The namespace should look like this. If you ran the code from the previous session, then we have this. We removed the header, the footer, privacy and error pages, and now we have just this left in our index view. You can see it here, where it will enable HTML content. This is the content that is displayed on the screen for now, right here in the index view. We don't need this, so this is where we are going to have the table. The table will be found here. Remember, we have a table in our application that stores IDs and tasks. Next, in this shared view, I'm going to create a new file for our form. Conventionally, we start with an underscore. I'll name this file _form.cshtml. Alright, we now have our form set up, and in here, we have the form. Later, we'll write the code for this form in this file and the code for the table in the index.cshtml. To make this form visible, we need to include it in our layout file using HTML helpers at html.partial. In our case, we want to display _form full stop. We use the html.partial helper method to render specific sections of our views efficiently. This method is instrumental in ASP.NET MVC for rendering a specified partial view as a string within the parent view. This partial method will display the form and is responsible for rendering sections that are not within the main content area, such as navigation or headers. This render body method will be used to display parts of the content page that do not belong to the named sections, ensuring flexibility in our view management. Now, to run this, we'll open the command palette. First, we'll need to reload the window for running the code. Let's run this code now. As you can see, the text we entered in the form and index files are displayed. So up here, we are going to have the form written in the form file, and down here, we'll have the table, which will be written in the index file. I'm going to close this and proceed with the code for our form. Now, in the form file, we'll write the necessary code. Here we have it. This directive specifies that the Razor view expects a model of type to-do item, which we've created in our models folder. It is used to bind data in the form, typically managed by the home controller. ASP.NET uses tag helpers to facilitate specifying actions in the controller that will handle the form submission. For example, the tag helper ASP-action specifies that this form is used to insert new items, and this method will be called when we press on the submit button. The method attribute is set to post because we are sending data to the database. This form will also display validation methods if there are any errors during server-side validation. Now, let's look at the input tags. Each input tag is associated with a property in our to-do item model, like the ID, which is hidden, and the name, which users can edit. The tag ASP-4 is used for binding the name property of our to-do item model to the input field, improving accessibility and usability. This setup helps in binding the field to the name property, meaning it will display any existing value of the name and allow users to submit changes back to this property. The ASP.NET Validation Summary helper is used to display a summary of all validation messages for the fields in the form, making it easier to show error messages resulting from server-side validation. Finally, the submit button at the bottom of the form will send the form data to the server when clicked, so it's of type submit. The form is styled and managed using CSS and JavaScript, with specific IDs used for easier integration of these technologies. We have the value here, which is used to label the button, in this case, add to do. Now, if we run this, you will see how our form allows the addition of new items. This is a basic setup, as you can see. I can type anything in here, and when I click on add to do, nothing happens. We are just redirected towards this local host page, which results to nothing for now. We will further enhance it by connecting to a database in the next lecture. That's it for now. See you in the next session, where we will create a database to store and manage these to-do items. Alright guys, in this lecture, we are going to proceed by creating a database that will store our to-do items. The first thing you need for this setup is the SQLite extension, since we'll be using an SQLite database. You'll need this extension installed on your machine to create and interact with the database. You can find this extension by searching for SQLite in your IDE's extension marketplace. I'll simply scroll through my already installed extensions. You can install any SQLite extension of your choice. We'll be using this particular extension for our project. Once you have it installed, you can return to our project and create a new file. I'll name this file db.sqlite. If you've successfully installed the SQLite extension, you can right-click on this file and choose Open Database. From here, you can create a new query. This query will be used to create a table named To Do. This table will have two columns, one for the ID of the items and another for the names of the items, corresponding to our model file to do items, where we have ID and name of the items we create. The ID will be of type integer and designated as the primary key. We'll also enable auto-increment functionality to ensure each ID is unique and automatically incremented. The name will be of type text and will be the actual task we want to do. This setup ensures each to-do item in our table has a unique ID and name. Once you've written the SQL code to create this table, you can execute the query. If you refresh the Database Explorer afterward, you should see your new table. You can as well come to this SQLite Explorer. You can see the table here, and if I click on this view icon, then you can see the table here. Let me close this. When I click this, it opens this SQLite view of the database. Initially, the table will be empty because we haven't added any data yet. In future lectures, we'll run SQL commands to insert data into this table. Additionally, to fully utilize SQLite functionalities, we need to ensure our project is set up correctly with the necessary packages. You can open the command palette, choose Add Nugget Package. Then search for SQLite and install the required packages like Microsoft.data.sqlite. Choose the version that matches the .NET version installed on your machine. I have already installed the necessary package, so I don't need to do this step again. Alright, that's it for now. We have successfully created our database table. In the next lectures, we'll explore how to add entries to this table. See you then. Alright guys, in the previous lectures we designed and created our form, which is used to input data for to-do items. We've also created the database. Now what we need to do is link both of them, so that when items are inserted by the user, they are stored in our database. So that's what we're going to focus on in this lecture. In our home controller, I've added an insert method, which takes an instance of the to-do item class from our models. This to-do here, which has the ID and the name properties. Here, the name of the method is insert. Remember, we talked about using the ASP-action helper in the form to send data to this insert method. This is why I've created a method named insert. Also, we'll use the post command to send the data. Additionally, we added the new get package, which enables us to establish the SQLite connection using this class here. This is an unmanaged resource, so we enclose it within a using statement, ensuring that when the connection is no longer in use, it's disposed of properly, not consuming much memory. We create an instance of the SQL connection class to establish a connection to the SQLite database, and we set the data source to the name of db_SQLite, which is the database we want to link this method to, this database here. After creating this instance, what we need now is to create a command. We create a command object that can be used to execute SQL queries against the database. We include this variable within a using statement. Then, by opening the connection, we set the SQL command text for the command object, which is the SQL command we want to execute. It can be to insert, update, delete, or simply read data from the database. In this case, we are inserting values into the name property in our to-do table. We only enter the name because the ID is automatically generated and incremented as we add items. We execute the command in a try-catch block to avoid code crashes or errors during execution. We execute it as a non-query because we are inserting data, not querying from the database. The catch block catches any exceptions that may occur during the execution and reports them to the user. Alright, let's run the code. Now, if we enter an item, for example, hello, and click on Add to Do, it will be inserted into our database. However, when we click Add, we are directed to this page here, but we want to be redirected back to our main page so that we can add item if we want to. We'll fix that, but before, let me show you the item in our database. If you open the SQL Explorer and click on Show Table, you can see the table. As you can see, the value have been added with ID 1, and the name that we entered on the form is present. This shows the insertion is working correctly, since we have found that the data insertion works. Let's ensure that we redirect correctly. To redirect to our original page, we need to change this to redirect to result. This change ensures that after the user adds an item, they are redirected to our main page. This URL corresponds to the port on which the website is being displayed. You can see here the link on which we are redirected is different. So, if you run this now, after stopping all running instances, you should see the correct behavior. Stop debugging. Then we run the code. Alright, here it is. If we enter another entry and click Add, the item is recorded in the database, and we are redirected to our initial web page with this URL here, just as expected. Also, if we go to our table, you can see a second entry has been added successfully. That's it for this lecture. We can now successfully add items into our database. So, I'll advise you to do this on your own so that you'll understand better. Remember, we learn best by doing. See you in the next lecture, where we will bring more modifications to our application. Try this on your own to ensure there are no errors with your database setup. Hello everyone. In the previous lectures, we established our database and linked it to the user form. Today, we need to fetch and display data from this database on the web page. That's what we'll focus on in this lecture. But first, I want to share a little modification with you. In the layout.cs HTML file, I switched from html.partial to html.partial async, because the previous method we used performs synchronous operations that can lead to deadlocks on the loop, which is a risk. Using html.partial async is safer, as it performs asynchronous operations. So, I made that change. Alright, let's build a model first. In our models folder, I've added a new folder named View Models. In this folder, I created a file named todoViewModel.cs. You might wonder what a view model is. It's a concept used to encapsulate data that the view layer needs to render, tailored to meet the requirements of a particular view. It often aggregates data from multiple sources or shapes the data in ways that are most useful for the view. One of the key uses of a view model is to decouple the presentation layer from the data access layer, ensuring the view doesn't need to know where the data comes from or how it's processed. It also enhances security by preventing sensitive data from being exposed inadvertently. I know all of this may sound confusing now, but as we go through the code, you'll understand better. So, don't worry. Here's the namespace for our view model. To do, models and view models. Then the name of the class, which is todoViewModel. This class includes two properties, a list of to-do item objects called toDoList for displaying multiple items. So, this actually just groups the to-do items in a list that we call the to-do list. Then we have the to-do property, which is a single instance of to-do item. This could be used to represent a specific to-do item in scenarios like editing or displaying detailed views of a single item. After defining our view model, we'll use it in a method called getAllToDos. This method retrieves all to-do items from an SQLite database and returns them encapsulated in a to-do view model. In this case, we are going to read the database and return a to-do list. That is an instance of this class here, with the property to-do list. That is why our first line here creates a new list that we call to-do list, and of this type here defined in our to-do view model. You should be familiar with this code already. This statement here establishes a connection to the database, then we create a command. Then we open the connection and we write the SQL command to select all entries, that is the rows from our to-dos table. Each entry is converted into a to-do item object and added to our to-do list. We'll create a variable reader that will execute our command against the database and return a data reader. Then we have an if loop that iterates over the data in the reader and converts it to the to-do item then adds it to the to-do list. So if the reader has rows, that is, if there is a data in the table, then we convert it into a to-do item model. Else if there are no more rows to read, we return the populated list. While we read rows from the table, we add these to the to-do list, but we add them after converting them to a to-do item object. We first read the ID. That is, we read the value in the first column as a 32-bit signed integer. This 0 here represents the first column. Our table is designed such that there are two columns, one for ID and another for row. So, index 0 is for the first column. In this case, column 0 of the row that is being read. And this one is the second column, which is read as a string and stored as the name of the to-do item. So, while there are rows that can be read from, we create a to-do item object. Remember, this to-do item we've defined here with properties, ID, and name. So, we give the object an ID and a name, then add this object to the to-do list. If there is no row, then we simply pass the current list to the to-do list. Finally, we create a new to-do view model, pass the list to it, and return it. This model is then used in our index method to pass data to the view, allowing dynamic HTML generation based on our to-do list. First, we call the getAllToDos to retrieve all to-do items from the database. The result is stored in to-do list view model, which is an instance of to-do view model. Then we pass it to this view that returns a view to the user. This allows the Razor View engine to use this model for dynamic HTML generation, where it can display the list of to-do items. Next, we will modify the index view to display this data. This directive tells the Razor engine that this view expects a model of type to-do view model. This is to make sure the Razor View recognizes the models that we use in here. We then use a table to show the ID and name from each to-do item, each as a column. The @for each loop in Razor syntax iterates over each item in the model's to-do list, displaying its properties in separate table columns. So, for each item in the to-do list, we print the ID and the name of this item. One other thing you've to do is, it's crucial to include a @using directive for the to-do.models namespace in the view imports file to make the to-do view model accessible across all views. This step ensures the Razor View engine recognizes the to-do view model when rendering the view, because if we just include it in here, it is not going to work and you'll have errors when you run the code. Lastly, let's ensure the form interacts correctly with these updates. We need to make sure the namespace is correctly referenced in the form view, and that the form submits data correctly, reflecting changes in the database. That is why I've made these changes here by adding to-do. As you can see here in the to-do view model, we have to-do objects, and each to-do object has an ID and a name. So, the changes I made ensure that each object's ID and name are referenced properly. Upon running this updated code, you will see the items from the database displayed on our web page just as we wanted. That's all for now. In the next lecture, we'll introduce more enhancements to our application. Alright guys, now that we can see the content of our database on the page and add items to it, what we need to do now is delete records. We might want to delete some items after they are completed or done. In this lecture, we will focus on how to delete elements. To do that, the first thing is to come to this index view and add other columns. Here it is with a class that will be later used to style the button using Bootstrap to make our website look good. We are going to add a button of type submit. The button will display delete, and on click, it will call a JavaScript method. This delete to-do method accepts the ID of the item as a parameter. This ID helps identify the item that needs to be deleted. This method will be located in a specific JavaScript file. The code for this method is here. This JavaScript code includes a function called delete_todo that takes an ID I. This function sends an AJAX request to the server using jQuery. This request targets our controller's delete method. The URL to which the request is sent corresponds to the delete method in our controller. Here, the controller, you can see the delete method which handles the HTTP delete request. You can also see that the type is set to post, indicating that we are sending data to the method. The data object within the AJAX call holds the ID of the element, which the delete method uses to remove the record from the database. Then this code here checks if the request is handled successfully. Then the page refreshes, removing the deleted item from the display. This refresh is triggered by the reload method. This reload method refreshes the current page, and that is after the element has been deleted successfully. So, when the page reloads, then the element will no longer be displayed. Now, let's look at the delete method in the controller. You can see here that it returns the result in JSON format, which is the format that is used to pass information between website and the server. Also, the method accepts an ID of type integer, which corresponds to the ID of the element we want to delete. This method establishes an SQL connection to our database. Then it creates a command that will delete the item from the database. Here we have the SQL command to delete the record where the ID matches that of the target item. Remember, we passed the ID here and sent it to this method in the jQuery request. This command will delete it from the database, so it will not be displayed anymore. We proceed by executing the operation as non-query because it's a deletion. This command deletes the record from the to-do table using the ID passed from the JavaScript function, which originally comes from the index HTML. If everything executes successfully, a new JSON object is returned, which triggers the success function in the AJAX call, confirming the operation's success. We keep it simple for this application. If the deletion is processed successfully, we return a new JSON object without additional data. We are not focusing on error handling in this scenario, where we will send extra data in case something doesn't work as expected. So, what happens is that when I run the code and click the delete button next to an item, the delete to-do method is called. This method will send a jQuery request to the delete method in the home controller. If the query is handled successfully, then we reload the page to display the updated table. In this delete method, we return a JSON file to indicate that the delete operation went out successfully. Now let's run the code and see. As you can see, we have a delete button near every item. When I click on delete here, then the item is successfully removed from the database and the page. This demonstrates that our method works as expected. To demonstrate further, I'll delete all existing items and add a new one, like cook. Maybe you want to cook, then click on add to do. You will see it correctly displayed on our page, reflecting our previous discussions on fetching and displaying data from the database. So it will query the database and get all of the to-do items, then display them on the web page just as seen. Now, we can also delete items if they've been done already. That's it for this lecture. In our next lecture, we'll explore how to update items. We'll introduce another button that, when clicked, allows us to edit the text of an existing item. Alright guys, in the previous lecture, we saw how to delete an item from our table. Now we are going to proceed by updating tasks. For example, if you have written an item and want to change it or add more precision to it, for example, that's what we'll focus on. I'm going to open the index file now. I've added this line here to add a button. Now, when you click on the update button, which is also of type submit, it will call this populate form method and pass the ID of the element attached to this button. This method is similar to what we've done previously. We pass the ID as a parameter, and then we have an AJAX request that sends an HTTP request to this URL. This one is of type get, because we are retrieving the element to modify it, not just sending data to delete. Here we have the data to be sent to the URL, which is I, the ID of the item to be updated. We're also going to return a JSON object. Now let's go to the URL and see what happens. In the populate form method, you can see it returns a JSON result type, which is the format we are going to use to send the to-do item. It also has the ID parameter, and we declare a local variable of type to-do item that is properties ID and name. It will be used to store the to-do item. We call the getById method by passing this ID. Let's first see what this method returns. It returns a to-do item which has the ID that has been sent from the HTTP request. We create a new to-do item. Then we establish a connection with the database here. We create a command, and the command will select a row from the table where the ID matches the one that has been passed to the method as a parameter. We execute this command using execute reader, which returns a data reader. We then save the return value in a variable reader. This data reader reads the rows, and if there are any rows, we assign the values to the properties of this to-do item we created here. We read the first column and pass it to the ID of the to-do item object we created, and the second column, which is the name, to the name property. If there is no row to read, we simply return an empty to-do item. After registering these items to our to-do item object, we return it. This JSON result serializes the specified data into JSON format for the response. When this JSON is sent, it signifies that the function has responded successfully. We are now going to use JavaScript to modify the HTML directly. This is where the HTML ID of the element comes into play. Populating the form means that when we click on Update for an item, it appears in the form, and we are going to change the value to that of the response, which is the name of the current to-do item. It is also going to attach it to the appropriate ID. Here you can see we already set the IDs of the input button and the form. So we use this ID to change the value of the button to Update to Do. You can see that the current value is Add to Do, and when we click on this Update to Do, it will trigger an action going to the Home and Update URL. Initially, you can see that the method attached to this button is the insert method, but then we change it to trigger the update method. This update method will store the new data in the database. We create a connection to the database, then we write a command to update the table by setting the name where the ID matches the element initially clicked. We only update the name as the ID remains the same. Then we execute the command, and in case there is any error, then exception handler will return a message describing the exception that occurred. After updating, we want our page to refresh to show the updated information. So we use a redirect result to return to the main page, which is given by the URL here. Alright, let's run this code. You can see when I click update, the form populates with the current item's data, and the label of this button changes to update item, and the action also changes to trigger update method. The HTML element reflects the name and ID that we have here, which will be used to update the value of the ID and the name of the item. In the form, we are now able to update, for example, this to cook this evening. When I update, the page refreshes and the data changes accordingly, and the action has returned to insert method. Also, you can see that the button has changed to add to do. Let's add another item, meditate, to see that it works. All right, everything is functioning, adding, updating, and deleting. That's it for this lecture. In the next one, we'll focus on styling our web app to make it look more appealing, but we won't delve into more complex functionalities outside the scope of this course. Alright guys, we have officially completed our website. We have created the form, linked the database, and we can now insert items, retrieve items from the database, and also delete and update items in the database. It's been a good job, though it has not been easy. I know it's been challenging, but I'll just do some small things to finalize our project. We are going to style our web app in this lecture. First, you can go to the index file to access the code. You will see some Bootstrap classes and other CSS styling. While covering Bootstrap is out of our scope, you can see how these classes are used to style elements. For example, the classes format these buttons here. I've also added some Bootstrap and CSS code to style the form, as mentioned earlier. I've also made changes to the layout view. You'll get these codes to help you understand better how things are done. The CSS can be found in site.css, where you can write your CSS code. For instance, this class styles the primary button, so you can customize the color. I advise you to experiment with the styling. For example, you can change the background image or color to personalize it. When I run the code now, you will see something like this, which looks more polished. You can add your styling, such as a background image, to make it unique. Here, you can see there's a new highlight when I click this, and I can add elements like go to school, for example. It comes styled, and here is another example. I can add something like learn Bootstrap and style my apps. You can see it updates successfully. Everything is going very well. The application is finally complete. As I said, I really advise you to study more on your own and go through the code. Let's briefly review what we have done. We started by discussing controllers, particularly in our home controller, where we implemented methods. We also talked about models and view models, like the to-do item model that we have been using throughout. We discussed how to communicate data securely through different views in the application. In the views, you have seen how we've integrated C#, HTML, and CSS using Razor View models, how to add a database to our application, and how JavaScript logic communicates with other parts of the system. We achieved some functionalities using jQuery and how to add CSS to our code. That would be it for this session. And by now, you should be able to communicate with the database successfully and add many more functionalities on your own. That'll be all for building a to-do web app using C#. I hope you found it interesting. In case of any confusions, you should not worry. All you have to do is to start the project back again on your own using the codes as guides, and I promise by the end you'll be surprised how easy all of this is. See you in the next session. Hello everyone. As we wrap up the C# Fundamentals course, it's essential to reflect on the journey we've taken and the significant progress you have made in understanding and applying C# in various programming projects. From setting up a development environment to mastering advanced features of the language, we have covered substantial ground. Let's consolidate our learning and highlight how these skills pave the way for further exploration and development in the field of software engineering. Now, let's recap our course and discuss what you can do next. We started with a comprehensive understanding of C#, beginning with an introduction to C#, its evolution, and its fundamental elements. We discussed core programming constructs in Module 2, where we grasped essential programming constructs such as variables, control statements, and loops. The development of the Task Manager console application allowed us to apply these concepts practically, enhancing our understanding of C# in managing real-world tasks. Then we proceeded with object-oriented programming in Module 3, which was crucial as it introduced us to concepts including classes, inheritance, polymorphism, and encapsulation. The Student Grade Tracker project was instrumental in showing how these principles can be applied to develop complex programs. We also explored C# 12's new feature of enhancements, understanding the modern capabilities of the language that can reduce code complexity and increase efficiency. In Module 5, we focused on robust error and exception handling techniques crucial for building resilient applications. Following that, in Module 6, we delved into file I/O and data persistence, providing insights essential for applications that require reading from and writing to files. We discussed LINQ for data management functionality, which opened new avenues for integrating query capabilities directly into the language. We concluded by applying all of the previously learned knowledge in Modules 8 and 9, where we developed graphical user interfaces and web applications using WinForms and ASP.NET Core. This not only enhanced our technical skills, but also our abilities to integrate user interface design and back-end processing effectively. This journey has sharpened our skills and given us a comprehensive understanding of what C# is and how to implement it. As you conclude, remember that your journey with C# does not end here. The projects and concepts serve as a foundation for further exploration into more complex systems and applications. Whether you're diving into ASP.NET for web development, exploring mobile applications with Xamarin, or integrating more advanced data handling techniques, the skills you have acquired serve as a solid foundation for your future endeavors in software development. Continue to practice, explore, and challenge yourself with new projects. Thank you for your hard work and dedication throughout this course. Your journey through C# 12 fundamentals has equipped you with the tools and knowledge to build sophisticated applications and positioned you well for advanced studies or professional challenges in programming and software development. Thank you for being with me throughout this journey.